everyone. It's my honor to welcome all the participants from various esteemed institutions across the country to the AICT Atal sponsored online 6-day faculty development program on sustainable biofuel from AGRI and AGRO-INDUSTRIAL waste by microbes, organized by the Department of Biotechnology at Sri Venkateswara High-Tech Engineering College at Animas from February 24th to March 1st, 2025. Once again, I extend a warm welcome to all of you for the inauguration of this 6 days FTP program. To formally begin this program, I kindly request Dr. P. Ramalingam sir, Head of the Biotechnology Department at SVHEC, to deliver the welcome address. We welcome you, sir.
Thank you. Good evening, everyone. Yeah, very warm welcome and greetings to all the present here. Yeah, special welcome to the Chief Guest, through GP Kettimuthu, Joint Secretary, Sri Venkateswara Education Institutions. It is an honor to be graced by his presence for this inauguration of this AICTE Atal online FDP for inaugural address. I am also privileged to welcome Dr. P. Thangavelu, Principal, is a mentor and guiding force for facilitation of this function. On behalf of Sri Venkateswara Institutions, I am honored to welcome all the researchers, scientists and professors for this Atal ATP. I would like to welcome our chief speakers and facilitators who have generously agreed to share their expertise with us. And your dedication and commitment to this FD program are generously appreciated, and we are happy to welcome all the participants for this Atal 6 days online FDP. I welcome everyone. Thank you.
Thank you, sir, for your insightful welcome address. Now I would like to invite our respected principal, Dr. P. Thangavelu sir, to present a special felicitation. We welcome you, sir.
Good evening, sir. Are you able to hear my voice?
Yes, sir.
Yes, sir.
It's audible.
Thank you. Thank you very much. Thank you. Good evening to everyone present here. It's my great pleasure to extend my warmest greetings and heartfelt congratulations to all the participants and the session experts, management, vice principal, dean, COE, faculty members, coordinator and co-coordinator of the inaugural of this faculty development program on sustainable biofuel from agri and agro-industrial waste by microbes from 2024 to 2025 to 1st March 2025. First of all, I would like to thank the AICTE Atal for sponsored to conduct this FTP at our campus. In fact, this program earlier scheduled to 10th February 2025 to 15th February 2025, but due to unavoidable situation, we were unable to conduct this faculty development program. Again, we request AICTE Atal director to permit us to conduct at a revised date, and they accorded, and this faculty development program started successfully today. I express my personal thanks to Professor Dr. P. Ramalingam sir, HOD of Biotechnology, who is the coordinator, and Professor N. Tirunana Sambandam, HOD of Civil Engineering, is the co-coordinator. Both of them tirelessly worked to bring this program in a great way. All the participants well aware of the purpose of Atal FTP for upskilling of the faculty in their field. The objective of AICTE training and learning is to impart quality training through faculty development program for postgraduate students, research scholars, and faculty members. So that faculty will have a sound domain knowledge and associated with skills set to apply in real life with industrial connected and equipped with institutional leadership skill for academic leadership. Similarly, understanding their roles in community well-being, nation building, and also their own career development. They also made ready with pedagogical requisites, teaching skills for instruction delivery, so they can effectively communicate knowledge and skill set to the students in a efficient manner, and their teaching learning effectiveness in assessed. And for the students, it will motivated and fascinated to acquire knowledges and life skill and understand their roles in community well-being, knowledge building, and also their own career development. Accordingly, Atal Basic FTP taught engineering core subject area, domain knowledge, and content related applied knowledge, lab practices related to the content, research avenue, industrial emerging trends, and related pedagogy approaches, including technological integration, comprehensive assessment, evaluation designing, both theory and practical, to empower faculty to achieve goals for higher education such as access, equity, and quality. About Sri Venkateswara High-Tech Engineering College, the college is located in south of India in Tamil Nadu, Erode district on State Highway 15 at Gobichetipalayam, and was established by Sri Venkateswara Education Charitable Trust in the year of 2008 with a main objective to provide academic excellence to all the citizens of the rural society. The trust focus on imparting quality education, disciplined integrated personality development, research management skills to face the global challenges. The campus with the extensively landscaped garden harmoniously. The SVHEC proud of state-of-the-art teaching and laboratories. SVHEC has a computer laboratories throughout the campus carrying the latest software and hardware in general and specific subject. The trust having group of 11 institutions including state and CBSE schools offering primary and secondary education, engineering autonomous, polytechnic college, paramedical college, arts and science, nursing are the running successfully under the umbrella of Sri Venkateswara Education and Charitable Trust. This faculty development program is held at Sri Venkateswara High-Tech Engineering College. The college approved by the IICT New Delhi, affiliated with Anna University Chennai, ISO 9001-2015 certified institution, accredited with NAC A grade and NBA accredited with 4 courses, civil, CSE, EEE and mechanical. It is an autonomous institution from 2023-24 academic year onwards. The college running 12 BE BTech courses and 3 ME courses and MBA courses. MOE with IIT Madras, CFI, virtual lab training with NIT Karnataka. This year is the 17th year of our college. The college has been given good support and atmosphere to students to excel their knowledge and skills. This program brings together a distinguished gathering of researchers, academicians and professionals, all committed to the noble causes of sustainability and innovation biofuel productions. The global challenge of energy security and environmental conservation has underscored the urgent need for alternative, eco-friendly fuel sources. Agricultural and agri-industrial waste, often considered as a burden, holds immense potential as a renewable resources for biofuel generation. Microbial technology offers an innovative and sustainable approach to converting this waste material into valuable biofuels, reducing our dependence on fossil fuels and promoting a circular economy. Through this FTP, I am confident that our esteemed resource persons will shed light out on cutting-edge advancement, innovative techniques, and real-world application in this domain. This knowledge gain here will not only enhance our academic and research endeavors, but also inspire the new solutions for sustainable energy. I extend my sincere gratitude to the organizers, experts, and participants for their dedication, and enthusiasm in making this program a success. May this FTP serve as a catalyst for meaningful discussion, fruitful collaborations, and pioneering research in biofuel technology. Wishing you all an enriching and insightful learning experience. Thank you. Over to MOC.
Thank you, sir, for your kind words and wonderful felicitation. Now, I request our esteemed Joint Secretary, sir, Dr. G.P. Gettimuthu, sir, to deliver an engaging inaugural address. We welcome you, sir.
Good evening, sir. I am very glad to take part in this discussion as a joint secretary. Our principal explained all the facts and figures regarding the school and its status. Now I'd like to discuss with you about the importance of the sustainable bio-waste, bio and agri-waste and industrial waste. This is a common phenomena in this world, because everybody should be equipped. Everybody should be given the task to remove all those evils and to use all the things which could be available from the wastages. Because the population exports in extraordinary way. So we cannot find new things. We cannot introduce new things. But we cannot use the wastages as a waste. So we have to produce all the things. We have to find out the new ways and means. Just for example, petroleum is the time of just making it, at the time of in the industry, first the tar was produced. Then lot of disease happened, even the cattle have been trapped by that. And then they made chemical and other advancement leads to the foundation just getting the new things of what is this polyester, fiber like that, So same thing happens in everything. All the bio waste and micro waste can be utilized. Then we can avoid the wastages. In spite of that, we can get all the new materials which would be very useful for the mankind. So for this, all the faculties must have the interest when they are teaching the classes, when you are taking the classes, they are giving new ideas for the students, because lot of students are coming here with all the enthusiasm to enter into the world's development and for the nation's development. So they should be given a challenging task. They should be given the ideas to where they can find the new ways and means to develop skills to serve the world from the fuels, serve the world from the wastages. In spite of that, if you are able to develop it, then we can have a good world with new things, with neat things, and clear things also. So even for the water, just we are getting the drinking water from the ocean. Such a way we must not waste any wastages as a waste. It should be properly utilized and it should be taken into account that all the young minds should take their chances to invent the new thing, to introduce a new thing for this world, which could be erase the wastages and the problems of hoarding it, everything like that. Even see all the materials when they are preparing, they are got waste. But now latest materials, a lot of things have been reproduced and they are brought into the usage of the mankind. So all the faculty members everywhere in the world, they must be given chances and training and ideas to innovate, to produce a new things which need not be the new invention, but to use the wastages and get back the new thing which could be utilized for the benefit of the mankind. That is the main essential thing. So this faculty program is a very good thing, and all the experienced people should guide them and to make them to think about the new ways. So that is very essential, because if we are giving them ideas, they will go forward. They can gather the boys, they can give the new engineers and scientists and microbiologists and the chemists. They can come forward. Even the anasim has been prepared for the waste of the petrol. So it is we are utilizing everywhere. So all the things we are need, we can get it from the wastages. Only thing is that we have to think about it, without which we cannot get anything, Just introduce a new thing is not a good thing. But leaving the wastages as a waste is a foolish thing, We have to find the new ways and means. And we should see that definitely there will be way for the production of the new things from the wastages of microbes or the industrial waste and bio waste and all things. So all our people will give the ideas and the members of this group should just discuss about the ways and means everywhere to develop the new nation with the protection of the abolition of the wastages as the new production which could serve for the purpose of the nation and for the people. Thank you very much. Thank you. So I want to finish my speech with the request that all my faculty members in the future and they should think all the new things about it. Thank you very much. I would like to finish my speech. Thank you for this chance and all of us should take part in this program and make it successful. Thank you.
Thank you, sir. Thank you for your interesting inaugural address. Now it's the kind attention to the participants. This is the message for participants from the organizing desk. All the participants are requested to stay in the same link for the session 1 and session 2. There is no separate link for session 1 and session 2. You can use and you can log in the same link for the session 1 and session 2. Now we are announcing that the first session will be start sharply at 6:20. Thank you all for attending the wonderful inaugural function of this 6 days FTP. Thank you all the participants.
Yeah. Shall we start, sir? Yeah.
Okay, sir. We want to give chief guest introduction, sir. After that, we will start,
Yeah.
sir. Okay, sir.
Sure,
We will,
sure.
sir. Vignesh, sir. Vignesh, sir.
Okay.
Yeah, okay,
Sir.
sir.
Thank you participants for your patience. Now on behalf of Sri Venkateshwara High Tech Engineering College, once again I welcome all the participants to the first session of AICT Atal sponsored 6 days faculty development program. It's my privilege to welcome our resource person of day 1, session 1, Professor Dr. R. Balakrishna Raja sir from Bannariamman Institute of Technology, Satyamangalam, which is located in the Erode district of Tamil Nadu. With your permission, I would like to present a brief introduction of our distinguished speaker of the session 1. Professor Dr. R. Balakrishna Raja sir is a passionate and accomplished scientist with over 15 years of hands-on experience coordinating all phases of government and industrial projects across the biotechnology and food processing sectors. He is skilled in managing and executing multidisciplinary projects, always committed to meeting targets and exceeding objectives. Dr. Balakrishna Raja sir completed his doctoral degree from Anna University in 2016 with a high commanded thesis. He began his career as an assistant professor at Bannariamman Institute of Technology in the year of 2009 and has since made numerous remarkable contributions. Currently, he serves as the Principal Scientific Officer and Head of the BIT Technology Business Incubator since February 2022, where he oversees over 22 incubator projects aimed at improving processes and workflows while ensuring compliance with the market demand and social sustainability. Dr. Balakrishna Raja holds more than 6 patents in fields such as nanotechnology, healthcare, food processing, IoT, and sustainable development. He has also secured a project funded with approximately 2.77 crores through seed fund grants and industrial consultancy projects. As a professor of biotechnology, he has facilitated the granting of 2 Indian patents with 5 more patents currently in the pipeline. He has managed research and industrial projects worth 28 lakhs in the field of agriculture, food and biological science and established a central facility for testing and instrumentation worth 38 lakhs. Dr. Balakrishna Raja sir has coordinated over 150 international and national events in the area of biotechnology and entrepreneurship development since 2009. He has published more than 42 patents, publications, and books, setting a high standard for future generations. Dr. Balakrishna Raja sir is a member of 10 professional bodies, including ISTE, Indian Society for Technical Education, and SFB, Society for Biotechnologists. He has received numerous prestigious awards, including the Best Young Faculty Award from the Nobel Research Academy, Pondicherry in 2019. We are truly honored to have such an eminent resource person with us today. With this brief introduction, I invite Dr. R. Balakrishna Raja sir to deliver his valuable lecture on the topic of processes and the prospects of bioenergy and circular economy, a way forward. We welcome you, sir. We are very eager to hear from you.
Yeah, thank you. And it's a very exhaustive introduction. So thanks for your invitation, as well as my special thanks to principal sir as well as coordinators of the event. Uh, can I share my PPT through now?
Yes, sir. Already I give a right, sir. You can share
Okay,
now.
okay.
Okay,
Just a
thank you.
minute. So let me share. Just a minute. Hope the slides are visible, sir.
Yes, sir. It's visible, sir.
Okay.
Visible, sir. Visible.
Yeah. So very good evening to one and all. I am really happy to take part in this AICT initiative of FDP, where many of our peers who are willing to know about the topic we can discuss, and this is the kind of some insights which I am sharing with you. I am just combining here both as a professor, where we have carried out a research. So part of work is also presented here, and also some of the ideas based on the incubation management, which can have the more commercial value, that is also presented here. So you can ask me doubt whenever you got. So this is the place I am coming from, Bannariamman Institute of Technology, located right at uh, nearby Satyamangalam on the Via Bhavani Road. So the topic I am going to talk today is exploring the sustainable solution for a greener future. So in the sense, anyhow, we are talking about the energy sector, of the sustainable energy sector, under which if you want to have the more energy to be either conserved or to be either uh, produced. So generation is quite costlier, whereas we have utilized more or less the conventional fuels. For example, coal, which is available to us. So all the coal samples, I think many admit requests are coming, sir, uh, in between. Yeah. So from the conventional fuels, whichever we are trying to take from the natural resources, we are exploiting that to the great extent, and I hope uh, soon or maybe in 20 to 30 years, we might have been all the fuels will be of depleted. So we need to find out a new source. So on that basis, there are plenty of non-conventional sources available, or what we call renewable energy sources, under which the natural elements like light, that is sun, which you are taking the solar system, so solar energy, and we are trying to harness the potential of water for more kind of energy, and also we are trying to exploit the wind, etc. So one or other way, we have some issues with respect to the other conventional means non-conventional sources. Whereas one such form which we have plenty of availability is the biofuels. The reason why I am mentioning here, we are trying to see everything in this world. It is nothing but a kind of biomass. So the biomass we are trying to take further, and this biomass can be altered or modified using some of the chemical reactions, and we need to manage that to produce more amount of energy. So that's where our challenge lies, and especially what we have done so far is conversion of biomass into energy. So what are biomass? First, we need to understand what is a biomass. So biomass may be a kind of wood, or it may be a animal manure, and also it may be a crop or a kind of producers, agricultural producers, or any kind of derivative obtained from the plant source or animal source like vegetable oils, etc. And also the waste which is coming out of the animals as well as plant materials, what we call as the sewage effluent waste or night soil waste, etc. So all these biomasses we need to rightly convert for the benefit of the society, especially for the livelihood improvement. So what are the main sources? We have majority of the source coming from the agricultural background. So agricultural background, it also encompass the residual material from the forest, also the crop waste rotational things, and somewhere during the storage of the post-harvest process, and some residues getting out of the grains, pulses, etc. So all such things contribute to nearly 40% of the total availability of biomass. Apart from that, you also have the waste materials like the perishable contents like fruits, as well as the food waste, that is processed food or the raw food, all the waste, also some kind of animal wastages. So all these things, and the sewage plant waste and power plant waste, refineries waste, all such organic material, whatever, wherever you have the carbon content, so that carbon content is the base material for your biomass. So here, what is the simple chemistry we are trying to work out is, we are taking the carbon and trying to form a kind of aldehyde, or what you call the basic biomass, that is CHO, that should be there. When you have that kind of biomass content, we try to convert that into a kind of pre-processed biomass. So that biomass will be able to recover itself by some kind of pre-treatment process. Then we are trying to convert that energy to produce a kind of fuels. Either it may be a biodiesel or a kind of bioethanol, that is short chain alcohols or long chain alcohols. So that can be done. So if you look at the key concept of how this circular economy is coming in, you can look at this process, whereas reduce, reuse, and recycle. So this being the key concept of your biogas or the bio renewable energy solutions. If you start looking at the feed, so this representation is nothing but a agave plant, whereas any plant material is given as the feed. So this contains many kinds of uh, what you say, that hemicellulose, cellulose, pectin. and different components are able to form the structural morphology of a plant material. So we need to homogenize the material first. So how we can homogenize? Either we have to go for any acid or alkali based pre-treatment or any biological method of pre-treatment. That's what we are trying to go for, digestion and hydrolysis process. So that's simply called the feed processing. Once you do the feed processing, then we are going to implement the technologies to convert the complex sugar into simple one. So that's where our biotechnology is more helpful, where the fermentation, the concept of yeast or any bacteria or any microbial source which is trying to convert or degrade the products, that is the complex sugars, then we get the simplified product. This simplified products are nothing but which may be a precursor or itself is a product of your biogas or ethanol or biodiesel, etc. Especially in the case of biodiesel, you might not have the fermentation where the trans esterification process is much helpful. So that is how you look at the feed, which is having a recycling and it adds value to the economy. And this is how we call the circular economy. In the sense, whatever we get from the uh, plant, that is the land, we are trying to give back to the land without being wasting somewhere. That's called a zero wastage process. The world is looking into the zero wastage process. I hope there are two targets you might be very much aware of for the India. When you say it is the Viksit Bharat, that is 2047, we have fixed that India should be self-sustained in all its sectors. Especially the key focus is on the biomanufacturing and the bio E3 process. As per the present central government's agenda, we need to focus and work towards that biomanufacturing. And also 2070, they try to uphold the concept of net zero, that is carbon net zero process. So this is again in turn much helpful to majority of this outlay. The idea behind all such things is based on some discussions what we had with some of the key personalities in during the project presentation reviews, etc. The government policies are aiming to see India as the globally we need to stand tall in the sectors related to the biomanufacturing and bio. We try to produce a biological hub. So one arm is working towards the medical sustainability, and also other arm which works towards the problems associated with the environment, and another arm where we are trying to focus on the energy demands. So here we are having this energy demands which is focused by either of the biofuels which is being generated under different generations. I hope all of you are aware that biogas is the day old process where DRDO has given its license free of cost and it's still available in the website as well. Still, many industries or many kind of village household and some of the rural foundations, they are working on this biogas plant, which they have primarily constructed using nowadays the night soil waste as well as the food wastages. If anything of a community, they are trying to construct that, and this biogas is being utilized for its own kitchen usage, whereas at least 40 percentage of the total energy is being the demand has been supplied at least. And also there are certain other aspect of first generation. We started utilizing the biodiesel where we try to take the oil from the vegetable seeds or some kind of plant seeds, and we converted that bio oil into a biodiesel through some esterification process. So that is again possible, which has been successfully implemented. But the difficulty in that case is two problems, whereas we need a huge volume of raw material, which is primarily a difficulty process. when a plant is associated. And the second thing is, it is also the the efficiency is not much high. So the efficiency is very lower. So we try to look at the other source where bioethanol production from some of the key components like cellulose or sugar and starch. Again, when it comes to the bioethanol production, we are not connoisseur during those times. Still, we try to produce much higher amount of ethanol from the maize, corn or maize. But there is a debate which occurred during the Brazil and the US, stating that the corn is used for food purposes. If you look at the usage of corn, America's staple food is almost the utilization of corn only. And also look at the Cuba, who is trying to give the sugar cane. They are the leading producers of ethanol during those times. So the federal government of US as well as other associated nations, they try to raise the issue like food for fuel. So either we need to have food or we need to get fuel. So on that aspect, the second generation of biofuel has been developed, which constitute a little lower chain alcohol called biomethanol. So under the biomethanol, there are different sources we can use for producing biomethanol, especially a chemical way of producing from glycerin, or we can use the municipal waste or bagasse or straws and some of the plant material waste, that is any nutshells, which we have to convert for the production of biomethanol by utilizing the proper microorganism. That is one way. Apart from that, the second generation also given a hope for a new concept called hydrogen production. You know, the hydrogen is one of the purest form of energy which we can consider. So this hydrogen, how we are producing is through synthetic way. So that's possible with the second generation. However, there is a gap in the biofuel generations because of we are either going for the waste materials, which is insufficient, or either going for the food, which is again a problem with the human food demands. So then there comes a void, and this was filled by one major group of organism. That's what we call either it's the macroalgae or the microalgae. So both this microalgae and macroalgae are able to capture the carbon dioxide. Once we capture the carbon dioxide, then it becomes a biomass. So this biomass can be simply we can convert that into your biofuels. One issue is the one genus or the one species of the algae which can be used for single cell protein. So either if you want more amount of such protein, we can grow always. So for that, the concept of photobioreactors and other things have come into picture. Still, the algal based fuel generation is very efficient unless until we should be thorough with the technological advancements. That is a one factor which we need to consider. And apart from the algal based, cyanobacteria is a new group of bacteria which has means again algae which has come into picture. It has simplified the process because you can maintain it as a bacteria and you can get the result as equivalent to that of algae. So that's how the fourth generation of biofuels also being practiced. So now the issue we are trying to go for more amount of either the biohydrogen production or a kind of
அம்மா தூக்குவாங்க. Yeah.
hello biohydrogen production or a kind of um, biofuel production. So now the government initiative have started looking at either we can go for the ethanol as a blend, that is 20 E20, in the sense any fuel whichever the engine needs to be modified according to the fuel capacity. So because of those issues, they've tried utilizing the 20% of ethanol to be blended along with your petrol. So that way also people try to manage all these things. But one key factor what we need to consider is we are trying to minimize the input resource, in the sense we don't want to take the food what is available for either human or animal. Also, we don't want to go for more waste, because we are trying to prevent the waste generation as well. So that is the only possibility where we can increase or regenerate our environment. So to have such environment, you need to optimize between these two parameters, the resource input as well as the waste prevention. Both needs to be managed to better utilize the nature. In that angle, if you look at, the algae is the best way of using that. Also, the government have generated some policies based on such aspects. Like if you have the material recycling, then it has some kind of credit is given. Nowadays, you would have heard about two major initiatives by the almost all the nations. They started following, especially the Finland and Switzerland. They are following the green credit, in the sense what we are having some what you say, the reward points with respect to the credit card usage, etc. So like that, whatever the material you are buying, so if that material is going to be a kind of green utility, means going to be of like what you say, it's not going to increase the greenhouse gas pollution, then that kind of product will have some kind of points given to that. So based on such sustainability point, they say that this is something called a green point or sustainability point. So which can be used to uh, what you say, the citizen of that particular nation is given some reward based on that. So this is also being practiced from almost all the nations. So soon it may hit us also. Also, if you look at some of the companies which claim that the carbon credit, so if they say like this much carbon credits we have saved, we have not means we are trying to contribute towards the net carbon, something like 20 means we have saved almost 20 percentage of carbon footprint, means they will give some kind of credit, in the sense monetary benefit is also given to that. So these are all certain things which are coming into the economical point of view, how these points are being utilized, etc. Hello, am I?
Yes, sir, you're audible. Please go ahead.
Yeah. So this is one industry which is working on this line of bioproducts into a soil health. So how these bioproducts are being utilized? One, yes.
So PPT is not audible.
Just, is it visible?
No, sir.
No, it's not visible.
I think somewhere.
I think you stopped sharing. Maybe you have to reshare.
I'm using the one more.
Sir, PPT share was completely disabled, sir. That's why. We just share once again, sir.
Yeah, just a minute.
Okay, sir. Okay.
So is it sharing now? You can look at.
Yes, sir. Now it
Yeah,
now it
yeah.
is.
The connection lost in the laptop. Sorry. Yeah, so this is one company called Agri-Tech Innovation, who are very recent. They are into the bio-based fertilizers. So what they do is very simple. They, instead of giving the manure or fertilizer directly, they try to adapt to the soil condition. They give the vermicompost. So they simply try to alter or enhance the soil capacity so that the plant can able to take the material direct from the soil. So this kind of thing, instead of going for a vermicompost, directly giving the fertilizer or a kind of bio pesticides or bio fertilizers to the soil, we are trying to enhance the soil health. So we are not doing anything new here. We are existing soil we are taking, and we mix with some kind of uh, what you call that vitilators and fertigators, different kinds of molecules which are nothing but a bioactive molecule or a precursor which can enhance the capacity or the potential of the soil. So this concept, what we call or claim under the circular economy, instead of giving a new element to the existing system, we are trying to rebuild or reconstruct the already available thing with a little augmenting or a kind of activation. So this is how this company claims that almost 500 plus farmers in the Tamil Nadu transition, they try to improve the organic, that is organic farming. And you know, those who are into the field might know the difficulty in getting organic certifications. So they are into this field, and they claim that almost 30% of the soil health is improved by boosting the quality as well as the yield, etc. Yeah. So here I would like to add one concept, as many of us are coming from different background. However, if you look at that waste management and other kinds of conversion, one recent application, what we are looking at is the usage of the fuel cells. So can you able to utilize the farm for the production of something electricity or kind of thing? Because people we are talking, when you talk about the energy sector, now you look at the automobile industry, there is no motor at all. Directly we are having the EV, electrical vehicle, where you need not go for fuel, etc. It has its own positive as well as negative. However, as a technology, people are trying to adapt to the newer or upcoming technologies. Still, we need to understand its effect in future. Okay. So with that conditions, so far what we have discussed is either the biomass conversion under the anaerobic digestion or thermochemical processing or a kind of fermentation. Next, coming to the bioelectrochemical systems. So this bioelectrochemical system has also grown along with these terminologies for effective utilization of the biomass to produce biofuel. Either the biofuel, majority of the case, it is going to be the biomethane as well as the biohydrogen. Because up to biogas, you know that this is being produced or conversion of one form of energy to other form. But now people are directly looking at for this much amount of input, how much is the electricity produced? So if you have such questions, you need to understand a system. So here I have given a system outlay where you have three lines, that is the chemical energy line, electrical energy line, and water circulation, which is also portrayed here. This is the combination of a shrimp cultivation in a pond or a lagoon with some surface aerators as well as the agitators, paddle agitators. So with that aeration, we form some kind of sludge which is being filtered and given to a kind of reactor. So similarly, you have a carbonization mechanism, like converting a sludge into a carbon. So that carbonization mechanism, which is giving means which is being circulated with the crop production. Either it may be a nutmeg or it may be any plant producing means any plantation based biomass, etc. So whatever it is, the residue is given as an input to the biomass, sorry, that is the reactor, along with your sludge, filtered sludge from the shrimp cultivation, which is being producing some kind of biogas. So this biogas we are trying to give it into the fuel cells. So fuel cells are nothing but we have a proton exchange membranes. So that proton exchange membranes will be given a exchange of a current which travels from the anode to the cathode. So this potential difference will be taken as a current, and the removal of heat will be continuous. So this is how the fuel cells works, and this YouTube you can look at how this fuel cell working principle as well as very simplified way of constructing a fuel cell is also given. You can try with your laboratory as well. You should look at the different types of fuel cells especially. So the first question is why, that is the why you need a fuel cell. That is the first question. To get any kind of energy which is of purest form. Even biohydrogen, it is considered as purest form. Still, people try to refine that process and produce more amount of purest electricity as well. And they try to claim that as the bioelectricity. And this bioelectricity, what will be the potential difference? That is the primary question. When you look at the biological, that is microbial fuel cells, MFCs, you have a very low frequency of producing current. That means what? You have a lot of issues related to the conversion. Especially the solid-based microbial fuel cell have more issues. And also when you look at that membrane-based, when you have some kind of PEM, that is proton exchange membranes, that membrane have very good way of distinguishing, or it enhances the probability of the contact between the electrons, so that electron when it touches, it has the potential difference. So that potential difference can be collected and it can be stored in the batteries in the form of current. So you have to understand where you are going to use this system.
We lost your voice. Sir, we lost your voice. We can't hear you.
Hello?
Yeah, we can hear you now.
Hello?
Sir, hear your voice. Please continue.
Yeah. So where we are going to utilize the system and how this is going to be the useful in the industry. So two key questions which we need to understand. For example, if you want to build a fuel cell at the end of your biogas, so all the biogas which is being produces, that can be collected, and that pre-treatment, that is we need to process that biogas and send it as the input to your fuel cells. So we will always have, when the exchange happens, you have the heat which is generated. So that heat has to be recirculated using a heat exchanger, so that this generated electricity being collected and stored in a battery, or it can be sent to the grid as well. So this is how this fuel cell can be used. So what kind of fuel cell and what is the range of the temperature, all such parameters we need to know. All of you know that oxygen is very essential for burning, right? So very means what I have shown is the proton exchange membrane, which is made up of the polymer electrolyte. So this polymer electrolyte, which can able to convert almost 60 to 65% of the conversion, and it works nearly 80 to 120 degrees Celsius. Okay, room temperature you get a very low efficiency, and also the typically based on the stack size. If you have some 6 to 15 layers of stacks, based on which different current can be produced, that is the kilowatts can be produced 1 to 100. And one issue with that is the very sensitive to the fuel impurities. We need to pre-treatment all the process and send. Otherwise what happens, the membrane life won't be there, and also the catalyst what we need to coat at the membranes are very expensive. So these then later people try to improve that by altering the sensitivity. So where we have tried to get alkaline based fuel cells, where aqueous potassium hydroxide, which is used in a ceramic porous matrix. So this kind of polymeric membrane is also giving maybe a kind of 100 kilowatts, and again the efficiency is comparatively better. Still it is not much higher than 60 or 65, and it is being in practice. When you look at some of the alkaline AFCs are being used in some of the polymer kind of industries as well. Okay, and this is also given in the science experiment for students as well, and it operates at nearly less than 100 degrees. So it is quite comfortable with some of the movable vehicles, that is transport. If you want to transport something from one place to another place, and you want to have generating electricity, for that kind of transportation, this AFC are better. And also the temperature wise it can be less than 100 as well, but efficiency wise quite lesser. And this phosphoric acid based fuel cells are also being used for distributed generation. Okay, but quite challenging is the it needs to means once you start it needs a longer time to activate itself. So also if any kind of impurities, since it is a phosphoric acid, as a sulfur comes in, it forms a kind of block, or you need to replace the membrane again and again, or you need to clean that membrane by some kind of membrane technologies, and then we need to reinstall. So this kind of issue is happening with the phosphoric acid based. Later we developed this MCFC and SOFC. These two things are much helpful to our MFC concept. But when you look at the temperature range, the operating temperature needs to be more than 500 degrees, and the efficiency is quite good in the sense when you are trying to have this molten carbonate or solid oxide SOFC kind of fuel cells, both can be very flexible and highly efficient in terms of the volume. For example, we can produce up to 3 megawatts of currents, and also the 2 megawatts of current. We can use this SOFC and MCFC, both are being used as very good technology for even corporate companies nowadays. However, the issue is the membrane. As you say, whenever we go for any raw materials, we need to convert that raw materials. Otherwise, it is the cost wise you need to optimize. So that is a very difficult or challenging task for us. So with that fuel cells, who are going to use that? Whereas waste to energy solutions, this is one company where they are trying to work on both the biological part as well as engineering part. They try to convert the organic waste into the biogas, and also they try to produce fuel cell based fuels, that is the bioelectricity from that biogas. So they are one such where they implemented this successfully for 1,000 plus rural households, and they are being used as reducing the firewood and the coal, that is the conventional materials. So what we are looking at in large is both the biological as well as engineering part has to be matched for the benefit of the ecology. So that's where our success lies, and this biorefinery kind of thing is suitably converted, then it is sustainable. If it is not converted, for example, if we have constructed the MFC and this is giving a yield of almost 30%. So operating a 30% efficient plant for with huge energy demands, etc., it is quite challenging as well. So economically it's not feasible. So people are trying to develop a sustainable process of both economy as well as the raw material balanced network. So we are trying to either use to reuse, or it is at the disposal we can go for remanufacturing, which can go into the production. And also we are trying to recycle the energy or material input. So this kind of usage or this kind of application we need to have with all the process, especially connected to the biofuels. We had a opportunity to look at the Adani power plant, which is located at this Karnataka, especially the Mangalore. Coal-based energy plant, but soon they are trying to convert that whole plant into a fuel cell based system for the better improvement of the clean energy. It means what? There is no kind of pollution or anything is seen, and also this kind of utilization is needed by the government of India, whereas they are trying to manage the animal manure, agricultural residue, and municipal solid waste into a clean energies, not like any kind of production. If you look at the first picture where biomass is being analyzed, if you have the potential plant like Praj Industries, which is having the plant at Pune as well as the Uttar Pradesh, and Adani Powers and Reliance, they are into this field, the modern development. If you look at the animal manure based conversion, you get up to something around 1.29 into 10 power 3. That much generation of your powers. So this itself is sufficient for your majority of the energy demands. So once you are self-sustained with the energy demand, then automatically the whole country can rely on this non-conventional or renewable energy source, especially from biomass, leaving the unaccounted other things like solar and wind and hydroelectric. All these three are additional boom. So imagine a country being generated and self-sustained with all these things. Apart from that, we have additional advantage, like we are using the biorefinery for this orange line. If you see this donut kind of diagram, you have all this process starting from the pre-treatment, hydrolysis, fermentation, and extraction, pyrolysis. So all this process, if you look at, it is associated with the kind of available technologies. And if you look at the peripheries, you have all the products associated. Okay, and it is from the source where from this biomass is being obtained. As we started from the beginning, either it's the animal sewage or waste of the cooking oil and forestry crops. Forestry crops includes the agriculture as well. So apart from that, the industry is also adding, because many of the industry certification is again dependent on your this green certifications. Okay, so with this we are trying to convert a pre-treatment process to a final liquid biofuels, and how we are trying to use that is one recent technology. I said microbial fuel cells are being used for clean hydrogen production. another technology for solid catalyst, if you look at, it is called a biochar. So here there are two factors. One is the biochar is being imported in huge quantity by our India, and recently if you look at many it is not a much hi-fi technology. We are trying to convert everything into the activated carbon. The biomass can be converted into activated carbon, and also the byproduct of uh, lignocellulosic acid, that is wood vinegar, that is also a byproduct for these things. Whereas we are trying to develop the biochar into a nano form of catalyst, which is a very good absorption molecule for the plant materials. So what happens, this can able to give the fertilizers very effectively, and this increases the yield like anything. So it has given a solution to the global issue of reducing the carbon, as well as recycling is possible. We can even reuse the land for more cycles of the production. And if at all any wastewater treatment and biolipid synthesis is happening, that is again helping to remanufacture the contents. And also the biopolymers which are used here can be used as the secondary material for the packaging, etc. So that way it is also used for maintenance, recycle, etc. So all these together constitute to the low carbon economy, and also constituting the high value of financial growth and the commercial potential. To add to this crown, we have the good facility of government, which is subsidies are being given for the initial development of technologies. Once we develop these things, we become the connoisseurs of the world, where we look at this biomanufacturing is a hub for the global uh, lead, which is nothing but our India can do all this by addressing all these issues, sustainability and also carbon management, and produce the bioproducts, which is value added bioproducts. So to do that all these things, what is the challenge? The challenge always lies in these three factors. One is the infrastructure limitation, because the present infrastructure may not be suitable for all this biochar production or microbial fuel cells, but we need to optimize between this infrastructure, and also the awareness and education, which can be imparted through the trainings, and also the funding and scaling, which is available to the people through the government of India nowadays. Soon the corporates also imbibed into this journey, whereas all the CSR funds will be routed for the betterment of the local society. So, for example, if a Zoho is available in Tenkasi, that area they are going to take some form, and they are going to infuse some kind of funds to develop this biochar plant, or a kind of wood vinegar plant, etc., or microbial fuel cell to generate clean fuels, etc. So any of the contribution is expected from such funds. So it is nothing but we need to optimize between these three, that is society, economy, and environment, to balance this energy, where energy is nothing but the Shakti to drive the any kind of production scope for the development. So here I have given a simple diagrammatic view of infrastructure to understand how these things are being used. Now you look at the methanol production. This is a gasifier or a cyclone separator, and using the scrubber we synthesize the methanol in the reactor and we separate. So this is a simple mechanism which we can use. So can we use the same for all these kinds of materials? Definitely no. We need to manage the sources accordingly. The downstream of the equipment also will vary. So that's what we say, the infrastructure is a challenge when compared to the any product which is being produced. So to each kind of products we need to separately develop the SOPs. So the SOPs are key in getting the efficient outcome. So starting from the coal or wind or ocean tides, hydro electrides, and first generation, second generation biofuels, Then we slowly into the microalgae lipid biodiesel production, and we even talked about the genetic engineering. But in future, what we are looking at is the enzyme based system of pre-treatments, and a kind of bioethanol production, and a kind of recycling the collected waste into different segments and using that. So these are all the future technologies which we are talking about, the fuel cells for electricity as well as the biochar or wood vinegar. So this is where we are standing now. In future, any kind of changes, especially the genetic engineering, people are now talking about the CRISPR-Cas. So the CRISPR-Cas can be used to specifically identify the gene responsible for the conversion of hemicellulose to simple carbohydrates. Then that can be very well utilized in homogenizing. So once the homogenizer is made simple, then the further steps are can be utilized with the same available technologies or available infrastructures. I hope I'm getting the point, and I hope you can follow me, right? So this is
Yes,
the
sir.
place where we are growing much of the paddy or pulses, etc. So this specific diagram showing a Thai farmer who is preparing organic rice seedling for sustainable food, and what they are taking is water, wind, wood, sun, and wave energy, and what they invest is economy, society, and the environment, and it is to the profit of the commodity, or to the people or to the planet. So this balance to be not exploited, then it is known as sustainability. When it is unsustainable, whereas all these things, agriculture, fishery, mining, energy, or habit loss, over exploitation, pollution. You can look at the condition of New Delhi as well as the Beijing, where the climatic changes. If you look at the Ooty or Kodaikanal, so all such things, any kind of deviation in this line is nothing but unsustainable. We are not able to look at the sparrows in certain regions, which is very much needed for the pollination and etc. Right? So I hope everyone knows about the story of Monsanto as well. Now it is the time to look at more sustainability and work towards the future circular economy in the biotechnology, where more innovative solutions and global sustainability as well as growth and investment are three key parameters needed for this processing. So if you look at the whole, the means crisp of what I have discussed so far is given here, and where we have to concentrate on is this bio innovation, agriculture, and forestry, smart farming. Whereas the listed contents are nothing but precision agriculture or internet of things, artificial intelligence for the analysis of all this soil nutrition, and low cost genotyping, gene editing, new generation breeding. All these things are very intensively used for the sustainability and the maintenance of your outputs. And also if you look at the processing, there are bio innovation and new efficient methods for lowering the energy and carbon is needed. And this is where more inputs are required. And also if you look at the bio innovation in the chemicals and bio innovation in the products, also the bioeconomy in the food and feed sector. So all these sector which are highlighted in rectangular boxes, we need to work out towards a more sustainable way of producing. So I basically look at the problems like this. The more you know, the harder it is to take decision. Once you become informed, you start seeing complexities, and you look that is a really problem, and you realize that nothing is as clear and simple as it appears. Ultimately, the knowledge what you have is dragging you to do that. But being a man of action, you take the risk and you look at the problem as a ignorant, and you will definitely have the solution. So problems are nothing but unless you try, you are not getting the solution. So with this small eye-opening message, I hope I have done with the presentation. I'm happy to address any questions from audience side and
Hello, Professor.
yes, sir.
Yeah, so this biofuel from fisheries, is it being widely applied in India today?
Sorry, just a minute. Yes, ma'am.
The biofuel from fisheries, how widely is it being applied in India today? And where all is it being applied? In which states?
Okay, fisheries. Yeah, we have this East Godavari, that is Aipolavaram Mandal of the I think Telangana now. They are utilizing that for the nano formation of the marine organisms are being utilized or exploited for your production of more what you say, the nano shells. Okay, so this being used for the biofuel production. So that is one area which I am aware of, and lot of research is being carried out in NIRI and NIO, National Institute of Ocean Technology. And this is one more thing is the if you look at the blue economy, now government is started funding for more startups in that area. So that is also being used for the production of this biofuel. So this is the one good source for the biohydrogen production, yeah, clean hydrogen production. Both you can go with the green synthesis as well as biosynthesis. Both are possible. Yes, ma'am.
Hello. Sir,
Yeah.
thank you for your presentation, sir.
Yes, ma'am.
Regarding ethanol in fuel, why it is not following in India, sir? What is the problem? Whether it is a cost or the waste utilization is not well versed established. What is the problem in establishing the bioethanol from the for the vehicles, sir?
Okay, so bioethanol, it's not problem actually. The reason is initially we started using the raw material which we are going to consume. For example, let's assume the corn can be taken by us. Instead of that, if you produce ethanol out of that, uh, you being filled with stomach is better compared to driving a car. So on that basis, initially there are some hiccups, but later the waste management, we are trying to utilize the waste resources and trying to produce the ethanol, but the efficiency or the conversion is not that much. So again, there is a problem which started winding around that. Later, we are having this algal generations. That is the third generation which has been come in. So the algal way of producing ethanol is better, as well as any feedstock conversion. If you have the very good pre-treatment method, the conversion is very effective. So on that basis, people are started looking at the pre-treatment strategies. So after understanding the homogenized way of producing raw material, then it is a very good way of giving. That's why the CSIR started utilizing 100% ethanol, and then government of India approved the E20 fuel. So the development has been in this field. It's not that stagnant, but now things are moving little faster compared to the earlier um, dates because of the government policies as well. So ethanol fuel is kick-started, and already Praj industry is being producing commercially. I hope you are aware of. Reliance is also into that market. Yeah. and somebody is raising the hand.
Sir, good evening.
Yeah.
Sir, I'm not sure with the research stuff. Do ethanol will corrode the engine?
No, no, ethanol. That's what. If you are going for ethanol, fully ethanol, maybe the engine modification is needed. That's what people have given research report, etc. And they say like started with E5 and then go up to E20. The engine, the same engine can be utilized for running. Even we have used E20 fuels for our own vehicle. We tried that, and the engine is good so far. That is the Suzuki engine. So I hope this engine modification is not a primary debate now, because people started moving into the electric vehicles. So people are looking at the clean energy production compared to the fuels. Again, the debate is based on why, means the application wise you have to strategize whether to go for the biofuel kind of thing or a manufacturing a gaseous fuel like biohydrogen. So more votes are given to the gaseous fuel because the transportation and other things are comparatively easy and effective. So there is no question of engine there. Yeah.
Gerard Maxide. Super Same,
Yeah, thank you.
Yanda.
I think Saranya, the third generation algal species, produce biofuel 1.83 gram from 1 kg. No, no. Yes, third generation algal species, they produce biofuel is very lesser compared to the biomass. That's true. And there are more methods are being used. And like, if I am correct, the Murugappa Chettiar group, they are working into very extensively on these areas. They have given a good efficient way. The trick is nothing but you need to increase your lipid content and also the conversion efficiency. If both are being optimized, I think up to the 2-3 generations they are giving a good efficient fuels. That's quite possible. And people are now working towards the biobutanol production instead of methanol or ethanol. Yeah. Some questions?
Yeah, so I wanted to ask, what is the kind of investment needed in these? I mean, there has got to be an ROI, right? So, what is the investment in these kind of things? Has that been estimated anywhere?
See, ROI is based on the process. For example, uh, we met Vidya madam from Reliance, that is who is working on these areas for the past 15 years nearly. Whereas all the products they are trying to launch, maybe in a short span of 1 or 1.5 years, within a year or 1.5 years, all the products will be launched one after another. Hope. In the sense they have, yeah, thank you, Prabhakar. In the sense the ROI is being calculated and it is being worked out. Instead of going directly into the ROI, they wanted to have their strong research base. Based on the research base, they have very well executed the strategies for developing the product. So that way, I think ROI is not an issue unless it is being studied thoroughly. Yeah.
Thank you very much.
Yeah. Thank you. I must thank my Professor Ramalingam sir. I hope sir is available. Is that fine? And any questions, sir?
Yes, sir. I have one question.
Yes, please.
Actually, fields having different properties like heating value, density, so many various in the properties.
Yes, sir.
Ethanol is having very low energy density when compared to other fuels.
Yes, sir.
But why government is still focusing only on ethanol? Because the higher order alcohol having higher energy density.
No,
But
I think if you see the revised guidelines, soon it will be hitting under Bio E3 policies. They are promoting biobutanol rather than bioethanol or methanol. Your question is correct. Uh, in the future, they are recognizing more for the biobutanol because of understanding the density issues and other things. To certain extent, we cannot go for the blend as well. So that's how the policies are also being reframed. I hope you get the point.
is it possible for having higher order alcohol like hexanol or
No, no.
octanol?
Again, the problem is very long chain. Also, it is a problem. The timing we need to optimize. For example, when it comes to the ignition, we are using the current petrol up to octane, right? Eight
Yes,
carbon,
yes.
yeah, up to octane it is possible. But the challenge with the biological process is 8 all is little difficult. Catalytic cracking it is possible, whereas biological way of synthesizing the fuel is bottom up approach. But what we are doing with the conventional fuel or the coal is top down approach. We are taking the higher long chain molecules and we are breaking catalytic cracking and getting decanol or octanol. Octanol is a pure fuel, and you are trying to reduce further. You may not get that fuel value, the density. Whereas biological way of processing, you can go up to 4. Then we can, what we can do is we can compare that, means combine that both 4 carbon alls to get a octanol like that. Some technologies are available, a kind of benzyne condensation or aldol condensation like that. So that way we can manage. Or you say the processed biological fluids fuels can also be used in future. That is one area where more exploitation is going on. I hope I answered your question, sir.
Yes, sir. But I have still one more. What about biodiesel? Biodiesel also higher carbon fuel. More.
Biodiesel again, the issue is it is derived from the either maximum from the plant or to some extent animal. Again, it is a trans esterification. It is not any biologically conversion or something. It is a biochemical reaction. And diesel, do you, when you say like continuous utilization of engine, modification is also required. These are all related to the economic issues, uh, not specifically to do with any technology. Yeah.
Okay, sir. Thank you, sir.
Yeah. Thank you.
Sir, I'm interested a little bit to understand how they market these products. One is to produce it, the other is to find the right consumer for it and sell it at a good rate in the market. How competitively are they doing it? Do you have any examples that I can, where I can speak to some people and understand a little bit more about the marketing side?
Ma'am, the problem of current thing is supply chain we already established. For example, if you have the petrol bunks or kind of um, what do you say, the Hindustan Petrol Limited or Bharat Petroleum, all these things, supply chain is well established. What we are trying to do here is the technological modification and advancement. So once you thorough with this technology, already the buyer is ready. Yeah. So directly they will procure more. Like that only we are trying to develop.
Okay, great. So, which means the end consumer has already been primed. You know, they have
Yeah,
facilities
we are only
to
the
store and
consumers.
capture. Okay,
Yes, exactly.
okay.
Horizontal lag.
Yeah, any further doubts, sir?
Participants, any other questions? I think Dr.
Hello.
Suraj.
Hello.
Yeah, yes, sir. You continue, sir. You continue.
Yeah. Okay, first of all, thank you very much, sir, for a nice presentation. I want to ask that what are the challenges associated to use this bioroot to produce biofuel? Hello, am I audible,
Sir,
sir?
I'm a
Am I
little
audible?
bit, sir. I'm not getting the question properly.
Hello. Am I
Yeah,
audible,
yeah.
sir?
Could it
Yeah.
be louder, sir?
Yeah.
Or?
Yeah. I want to ask that, sir, what are the challenges associated with by using the bioroot to produce the biofuel? Am I audible, sir?
Biofuel. Okay, the
Yeah,
challenges
yeah,
associated with the biofuel.
yeah. By using the bioroot.
Yeah, bioroute. Bioroute is one thing is the timeline. Uh, we we have not optimized the timeline so far, but to some extent, I think the leading companies, what I have mentioned is Murugappa is the research center, and Praj and the Reliance, they have done something on this timing as well. And also the infrastructure is the major constraint. However, we are trying to, for example, beyond certain level only we can produce. It's like we cannot produce a 50 liter or 100 liter for a plant, so we need to construct a bigger infrastructure, especially associated with the biorefineries or kind of thing. Then only it is very effective, and also the ROI, as someone questioned, that will be satisfied. So the challenge is one thing is as a technology itself, the time consuming. The second thing is the infrastructure, but soon we are getting a good outcome. It's having a lot of hope as well, right? And globally, if you look at India is having some better technology compared to anyone. That's what our government is also looking for, the Bio E3 policy to establish itself as the global giant. I think these are all the simple uh, challenge which we need to overcome. Once it is done, then fine.
Thank you, sir.
Yeah, thank you.
Participant, any other questions? Any other interaction you need of it?
Sir, good evening, sir. Sir, good evening, sir.
Yeah, good evening.
Sir, I am Lakshmi Prabha, sir. So my question is, if suppose we are using non-edible seeds as a feedstock, means what is the success rate, sir, compared to previous generation, sir?
That's what we had a very good lesson from the Jatropha. Bio
Yes, sir.
oil we have utilized, but many people have invested much, and the returns are not as much. The reason is, if you look at the seed, for
Okay, sir.
example, 4 and above, the tetraploid, that condition is very well suited for more oil production. So that oil production is proportional to the conversion into diesel. So as expected, the humans, we are deployed, and we expect this gene and this how it acts, and we do all the genetic engineering. But however, it is quite difficult for plants. As we expected, you cannot get the outcome. So the trouble is you are not getting a homogenized fat percentage or the oil percentage. So the requested conversion or the expected conversion is not happening. So that's the major difficulty in that things. I think much
Okay.
explored is the non-edible seeds. Still,
Okay.
the expected conversion has not happened. So people have dropped that idea.
Okay. Sir, one more question, sir. If suppose
Yeah,
we can use any catalyst for that, sir, for to speed up that reactions for that sir,
yeah,
conversion, sir.
definitely. Catalysts are being utilized.
Okay.
Non-metallic catalyst also used, but anyhow, biological catalyst can also be used.
Okay, sir. Okay. Sir.
Even though it is producing, you need to have the raw materials. No, I know that people have used almost 20 acres of land dedicated for Jetrofa, but
Okay.
not expected result have come. So
Okay.
that's
Sir.
the issue.
Okay, sir. Okay, sir. Thank you, sir.
Yeah, thank you.
Thank you, sir.
Participant, any other queries?
So just one more question I have, which is
Yeah,
that if let's say a fishery farmer, who's starting a fisheries,
yeah.
who would he go to for a turnkey consultancy in setting this up from the beginning?
I think there are a lot of incubation centers available. They will be better guiding that person. If you are very particular about location, I can still help you.
Yes, yes. I have a person who's starting a fishery farm in Karimganj in Assam. And I was
Okay,
just
Karimganj.
wondering if I could help him, start this from the beginning. It would be a good
There
case
are,
study.
yeah, yeah, there are a lot of players in West Bengal. I think Karimganj is hill
Assam,
related.
Assam, Assam.
Yeah, I know Karimganj area where it is the foothills of some hill. I have been to
Correct.
that place also, and there is a lake mostly associated with this tuberculosis related some strains we try to isolate there.
Oh, okay.
Yeah, yeah. I think West Bengal there are more players are available for this instance. If you want anything, please mail me. I will connect with them.
All right. Thank you so much.
Yeah, yeah. Thank you. There is one person who is working on aquatic probiotics, who is also available there.
Okay. Wonderful. Wonderful. Thank you.
Thank you.
Okay, sir. I think there was no more questions from participant side. Now I request K. Kadirvel sir from Biomedical Engineering to deliver the summary of keynote of this session.
Hello.
Yes,
Hello.
sir.
Yes, sir.
Good
You are
evening,
audible.
everyone.
Yes, sir. You are audible. You
Okay.
deliver.
Okay.
Okay, sir.
Okay. Good evening, everyone. As we have completed the first session of day 1 of the 6-day Atal FTP program, I would like to share that this session was presented by Professor Dr. R. Balakrishna Raja on the topic Progress and Prospects of Bioenergy and Circular Economy. Thank you, sir, for your valuable insights and presentation on this important topic. In this session, we learned about the significant achievements in bioenergy and how the circular economy can play a crucial role in creating sustainable solutions for the future. Sir clearly explained the need for energy production from bio-waste. We often encounter waste from various sources and we are unsure of how to eliminate it or transform it into useful products through the digestion of bio waste. However, in this session, we gained valuable insights into how bio waste can be converted into bioenergy and other beneficial products. Professor Dr. Balakrishna Raja Sir also discussed biomethanol and biodiesel as promising bioenergy sources. He explained their role in meeting the increasing energy demand, particularly in the context of reducing dependence on fossil fuels. Additionally, we learned about bioethanol, another important biofuel, and its applications in reducing carbon emissions. The session also covered the merits and demerits of these biofuels. While biofuels like biomethanol, biodiesel, and etc. offer significant environmental benefits, including reduced greenhouse gas emissions and a renewable energy source, challenges such as production costs, land use, and energy efficiency need to be carefully considered. Furthermore, the concept of the circular economy was thoroughly discussed. The circular economy promotes the recycling and reuse of resources, turning waste into valuable products such as bioenergy. By integrating circular economy principles with bioenergy production, we can create sustainable closed-loop systems that minimize waste, reduce pollution, and conserve resources. This approach is essential for addressing both waste management and energy challenges, driving us toward a more sustainable future. As part of this FDP, it is important to note that to fully meet the aims of the seminar, we as a faculty members must not only understand these concepts but also apply them in practical ways. It is our responsibility to incorporate this knowledge into our teaching and research, transforming it into actionable products and solutions that contribute to the success of this program and the broader goals of sustainable development. This knowledge will help us to address waste management challenges while contributing to sustainable energy solutions. Thank you once again, sir, for your informative presentation.
Yeah, thank you for your briefing. Thank you. So thanks all, and I thank very much to my Professor Ramalingam sir and the team as well. My special thanks to Principal sir as well. Thank you, sir. Thank you all.
Thank you, sir. So tomorrow we meet at the same time.
Sir, you have one more session, sir. Sir, Balakrishna Raja, sir. Dear participants, your session 1 feedback is displayed in message section, same as well as in our WhatsApp group. Kindly update your feedback that's based on your attendance. The next session will be starts at 8 p.m.
Okay, will we get the presentation that doctor presented today?
Yes, sir. Today, next session will be 8 to 9:30, sir. Already updated in WhatsApp group, sir.
No, I'm asking the presentation that Dr. Balakrishna presented just now.
Yes,
will
sir.
we get a soft copy of the presentation?
Yes, sir. I will update on tomorrow, sir, through WhatsApp
Okay.
group.
Okay, thank you.
Okay, sir. Thank you, sir.
Thank you.
Sir, hello.
Yes, sir. Yes, sir.
Sir, is there any way for attendance or it will be recorded automatically?
Sir, automatic record, sir, but feedback form is mandatory. I updated in message, sir. Okay. At the same time, WhatsApp group also, the feedback form session 1 feedback form will be updated, sir.
Okay, sir.
So kindly do your feedback based on the recordable attendance and the feedback only consideration of the Atal portal attendance, sir.
Okay, thank you, sir.
Okay, sir. Thank you, sir. Thank you. So, dear participants, please wait. Next session will be start at 8 p.m. Only 10 more minutes are there. The same link only we are going to follow. So please wait in the same link.
Hello, sir.
Yes, sir. Yes, sir. Tell me, sir.
As if now I'm not added in the WhatsApp group, will you add me?
Yes.
Sir, through message, I forwarded the WhatsApp group link, sir. Once again,
Okay.
sir. Actually, now you are in WhatsApp group or not, sir?
Right now, I'm not in WhatsApp group.
You are not in WhatsApp group.
Yeah.
Okay, sir. I think your mobile number may be available in the Atal portal, sir. Tomorrow morning, I will call you, sir. I will call you and add in the WhatsApp group, sir.
Okay,
Your
thank you,
good
sir.
name, sir. Your good name, sir.
Jinson Paul.
Jinson Paul.
Yeah.
Okay, sir. Okay, sir. I will call you on tomorrow morning, sir.
Okay, thank you.
Okay, sir. Thank you, sir. I think you
Hello,
just check
sir.
your mail ID, sir. Today also I sent the mail, common mail to all.
Yeah, I got the common mail, but I'm not included in the WhatsApp group. So I'm getting the mails.
Okay, sir. Sir, in this mail itself, I forwarded the WhatsApp group link. Anyhow, sir, tomorrow morning I will call you. No problem. Sorry for
Okay,
the inconvenience.
I will check it once more. Yes, yeah, sir.
Okay, sir. Okay, sir.
Thank you.
Dear participants, kindly switch on your camera for taking the screenshot.
Hello, sir.
Yes, sir. Tell me, sir.
I'm also not in a WhatsApp group.
Oh, sir, your good name, sir? Dinesh.
Dinesh Rajaraman.
Okay, sir. Sir, you kindly check your mail, sir. I already forwarded mail for everyone. Today
Actually, I
morning
received
also
a
I
mail.
forwarded. In this mail ID, it's a mail itself. I forwarded the WhatsApp group link.
Okay.
If any inconvenience, you just may. I will call you tomorrow, sir. No problem. I will noted your name. I will call you tomorrow.
Okay.
So how you joined today, sir?
Through the link I received in mail.
Oh, okay, sir. Okay, so in that mail itself, WhatsApp group link is available. At the same time, my mobile number also available in the group WhatsApp. Sorry, mail also.
Okay, sir.
Okay, sir. Thank you. Dinesh. Yes, sir. Sir, till some of you not switched on their camera, please switch on the camera. I have to take one screenshot. That's enough. Because we have only 8 minutes of time. Our next chief guest will join very soon. Please switch on your camera. I will take one screenshot. Okay, participants, thank you. Switch off your cameras. Next session will be starts at 8 p.m. You just wait, only 7 more minutes are available. The same link, you just wait. Good evening, sir. Sivakumar, sir, I think you are joined. Are you able to hear? Sir, whether it's audible, sir, you are unmuted, sir. So you are speaking, but you might, yeah. Now it's clear.
Now it is okay?
Yeah, sir, it's okay, sir. So whether it's audible, sir?
Yes, it is.
Okay, sir. Sir, shall we start, sir? Shall we start with the
Yes,
guest intro,
please.
sir?
Please go ahead.
Okay, sir. Thank you very much, sir. Ma'am?
Yes, sir.
Ma'am, yeah, you go with the chief guest intro, ma'am.
Am I audible, sir? Sir, am I audible?
Yes, sir. It's audible, ma'am. Audible, ma'am. You continue.
Okay. Here comes the commencement of second session. First of all, I would like to begin the second session by having an introduction of our honorable chief guest. It is an absolute honor to introduce our esteemed chief guest, Professor Sivakumar Udandi, a distinguished academician and researcher who has dedicated 34 years to academia, including 4 years in Tamil Nadu state government and 30 years at Tamil Nadu Agricultural University, where he served in roles from assistant professor to dean of postgraduate studies. He pursued postdoctoral training at esteemed institutions, including the University of Florida of USA, UK, Russia, and Netherlands. He was also recognized as a visiting associate professor in USA and has been an adjunct professor at the University of Tokyo, Japan since 2019. He has made pioneer contributions to microbiology and biotechnology. His work spans bacterial cellulose synthesis, biodiesel production, and plant microbiome research for disease control and soil remediation. With 171 peer-reviewed publications and 4 patents, which includes 1 from US and 3 from India, he serves as an editor for Spinker Nature's Indian Journal of Microbiology. He has secured around 1,471 lakhs in research funding and mentored 35 scholars across master's, doctoral, and postdoctoral levels through prestigious funding agencies. His achievements have earned him fellowship from the Royal Society of Biology, London, and the Academy of Microbiological Sciences, India, along with numerous accolades, including 4 international, 13 national, and 9 state awards, notably a Tamil Nadu Scientist Award. He continues to drive innovation in microbiology and sustainable bioprocesses, contributing significantly to agricultural and environmental sciences. With a remarkable career spanning global collaborations, groundbreaking research, and invaluable contributions to sustainable bioprocesses, he has been instrumental in shaping the scientific society. We are truly honored to have Professor Sivakumar Udanti sir as our chief guest for this 6-day faculty development program of Atal today. Without further ado, I invite Professor Sivakumar Udanti to deliver the chief guest address. Sir, this virtual stage is yours. Please, sir.
Yes, madam. Thank you very much for the elaborate introduction. I think the participants are, I see 116.
Yes, sir. Around 160 members are joined, sir.
Okay.
They may be joined soon, sir. Actually, I told that 8 p.m. only a session. We started our 5 minutes early, sir. That's why. They
Very
will
good.
join, sir.
Very good. Very good evening to all of you. I think she read out all my profile and the details of my career, awards, everything to you. Indeed, it's a great pleasure for me to meet you all through this online workshop. And I must thank Professor Ramlingam and Professor Thangavelu for inviting me to this workshop, and they only made me to meet you all through this online workshop. So the topic that I am going to present today, shall I share my slides, madam?
Yes, sir. Sure, sir. Sir, actually, one thing I have to convey here.
Yes.
Now we have very detailed profile, but due to some time constraints, I have elaborated only a brief note.
No, this itself is a detailed profile.
Okay, sir. Thank you, sir. Thank you very much, sir. Welcome. Yes, sir, you can go ahead with your presentation, sir.
Yeah, let me share the PowerPoint. Do you see my slides?
Not started yet. Yes, we can see now. Yes.
You can see now. Okay. Let me make it a presentable view. Whether the slides are moving? I am moving the slides.
Yes, sir. Yes, sir. Yes,
okay.
Yes.
Okay. Good. It's very, again, pleasure meeting you all. The topic that I'm going to talk today is microbial biodiesel production from waste. Under which, what are the avenues available for bio-based products, including biofuels and chemicals? So this is the title that I'm going to talk to you. And before I'm going to talk on the real topic, I would like to give you a quotation that life on the earth would cease to exist if there was no microbes. So please underline the word instead of water, I put microbes. Life on the earth would cease to exist if there was no water. You take the water and put microbes in that place. So that much importance it is. I hope you all agree with my statement. Yes? Yes or no? Okay, I agree with you. So before going to the topic, I would like to brief my place where I am coming from. It's Tamil Nadu Agriculture University, century-old university. So under this university, there were about 33 departments, and we are one among them. We are from the Department of Agriculture Microbiology. It's one of the oldest department in the university. We have started our department in the year 1971. Since from the beginning, we were recognized as so many centers of excellence. First by FAO, and another center of excellence by UNDP, and third center of excellence by ICER. And now the MHRD has also recognized our department as one of the centers of excellence in the country. So besides that, we are also nodal agency for biofertilizer production and quality control, which is one of the important input in the organic and sustainable agriculture system. And to look at our facility, what we have in the department is one of the Asia's biggest facility, Rhizotron. So this Rhizotron is meant for studying root system architecture. If you want to apply something on the seed, what is the changes that are going to take place below ground. So that can be viewed by imaging and viewed by biomolecule interaction in the root zone with the soil flora and fauna, and how the microbes are interacting with the root system. So all those things can be visualized and understood by studying various experimental setup. And here with this facility, we can also control both the above ground as well as below ground. So below ground in the sense soil pH, electrical conductivity, redox potential, all these things can be controlled. And on the above ground, light intensity can be regulated, carbon dioxide level can be fixed based on our requirement. Say, for example, if you want to conduct an experiment with the elevated carbon dioxide, so that is possible with this Rhizotron system. So what I'm trying to say here is both the below ground part and the above ground part can be very well studied with this Rhizotron facility. As I said, it's Asia's biggest facility, and the cost of this facility runs about 12 crore. You can imagine. So it is one of the dream project of our university as well as state government. And on the right hand side, you can see our accolades as far as our department is concerned. And in the middle of the slide, you can see what are the facilities that we have. Besides Rhizotron, we have several laboratories attached to this department. So all of them were focused, specialized, all about plant microbe interaction as well as the biofertilizer production. So the title, from the title, I made several publications. Around 15 of them were published and many of them were available online. So some of them are listed here, especially this one. The fifth one is a review where we wanted to give you a holistic idea about how the biodiesel can be produced using lignocellulosic biomass. And all the other things are research papers which are published in a high impact factor journal. You can freely download. Otherwise, if you have any issues in downloading and viewing these papers, you are most welcome. So this is a paper, review paper, which we have published in the year 2021. And after that, also we have published so many research papers. All of these papers are available with us. So this is outline of the talk that I am going to talk today. The biomass. What is biomass? What are the complexity and what are the issues and challenges in the biomass conversion? Those things we will be dealing. And then the rest of the presentation will be concentrating on the yeast biomass, because we have done a wonderful work on how the yeast biomass could be used for producing various biomolecules. So those information I wanted to share with you. And besides biodiesel, I'm also going to give you some of the co-products that are produced along with the biodiesel. And here in most of our presentation, we will be using the sago wastewater as a feedstock. And because the sago has a good amount of starch, we wanted to use that starch. So all the informations that I'm going to present are summarized in this slide as an outline. Okay, coming to the topic. Hope you all know about biomass. What do you mean by biomass? Plant biomass, or forest biomass, or wood biomass. What do you mean by that? Can any one of you?
It is the organic or the
Yes,
whatever
very good. It
material
is the
from plants, right?
plants, forest, waste. Yes, you are right, madam. It is an organic material rich of various polymers. So various polymers means cellulose, hemicellulose, lignin, all the three macromolecules are rich in this plant biomass. Say, for example, wood residues, wood sawdust, and crop residues. All these things are considered to be biomass. So we can call this, based on the composition, we can call this as a lignocellulosic biomass. So this is the main feedstock available in the country, not only in the country, all over the world. And being a tropical country, we receive more than 12 hours of sunshine. So this 12 hours of sunshine will help us to produce more biomass because of the photosynthetic activity. Whereas if you go to the Western world, where you will not get good sunshine, but limited sunshine, they are also producing this kind of biomass by growing specific crops like miscanthus, switchgrass. All those things are called energy crops. But for us, it is grown by itself. So we have to do is we have to make use of this biomass and work towards a positive direction to get value out of this waste material. Otherwise, these wastes are dumped, and the dumped waste can be burned, and burning leads to environmental issues, greenhouse gas emission, and then disposal issues. So many associated problems are there with this lignocellulosic biomass. So we can overcome all those issues. And if you look at what is biodiesel, it is that the fuel can be produced in general by jatropha oil, or by vegetable oil, or by sunflower oil. So all you need to know is we need to have a crude oil. So this crude oil is a starting material so as to produce biodiesel. So what I'm saying here is the crude oil is a starting material. So if I say crude oil means it's a fossil-based oil. So these fossil-based resources are going to be lasted in few years, few decades. So in that case, we have to switch for alternative resources. So alternative energy source is the lignocellulosic biomass. And here, yes, I hear some noise. Shall I go ahead? Okay.
Yes, sir, you can.
Okay. So this crude oil can be comparable with the microbial oils that are produced by its nature. So some microbes are producing this oil, and this oil can be compared with the crude oil of fossil material. So how this is possible? And there are certain groups of organisms under the yeastern fungi. They are called oleaginous microbes. So these oleaginous microbes produce oils to the tune of 20 to 70%. So that means you can imagine how potential these organisms are. So often we call this microbial oil as a single cell oil because the cell is able to produce oil. That's why we call this as a single cell oil. And as I said earlier, this can be comparable with the vegetable oil as well as oil that are produced from animal fats. And if you take the advantages of this oil, almost they are similar to the fatty acid profile of other oil that is being used for biodiesel production. And another biggest advantage of using this microbial oil is the life cycle is very short. So unless crop cultivation, unless tree cultivation, so here in a laboratory, within few days, you can produce good amount of oil. That's why we call this as a short life cycle. And then relatively lower environmental effect because the carbon dioxide emission from these processes are very, very limited and reduced labor demand. So if you are cultivating jatropha or sunflower, it requires lots of labor. So in this case, only the machines are going to do that, like bioreactors and other associated equipments will do the job of producing the diesel. And then convenience scalability. So if you want 1,000 liters of biodiesel, this can be produced with the limited time, limited resource, limited manpower. So that is the whole advantage of this single cell oil or microbial oil. And how this can be produced? So since simply by growing the microorganism, can we get this oil? No, it is not possible. The same organism, unless you switch the metabolism to produce oil, these organisms will not produce oil. So there is a switching mechanism. There is a limitations available in these organisms. Say, for example, limited phosphorus, limited nitrogen. Switch the metabolism of the bacteria or yeast or fungi towards lipid production. Otherwise, what is the fate of this oxidative process of any organisms? What is the fate of the metabolism of any heterotrophic organism? So this will lead to carbon dioxide production. So you will not be able to get lipids. So you have to know the critical point or limitations or the point at which the biosynthetic pathway can be diverted from carbohydrate metabolism to the lipid metabolism. So if you know that, it will be easy for you to produce good amount of lipids. And then if you look at the statistics from 2017, it was 25%. Now the requirement of this oil from the plant source or microbial source is getting increased. Maybe in 2050, you can expect 85% of the production is possible. And then by 2033, so there is a huge demand of 340 million USD is going to be the requirement from the biodiesel. So you can imagine how important the topic of our discussion is. So on the bottom of the left-hand side slide, you can see the total agricultural residues generated by various countries. So the crops waste that are left over from the field is also considered to be lignocellulosic biomass. So on the graph, you can see what are the materials that can be used as a LCB. In short, I can call LCB lignocellulosic biomass. Paddy straw, rice bran, cane bagasse, cane top, corn. All these materials, whatever comes from the plants or crops or trees, are considered to be lignocellulosic biomass. If you look at the country-wise details, so you can see India where it is. It is in the 4th position next to China, Brazil, and the USA. We are in 4th position, and you can see the proportion of each biomass represented by colored graph. On the right-hand side of the slide, you can see what are the organisms that can be utilized for producing biodiesel. So T stands for trichoderma, C stands for candida. So all these things are very, very important. And then what are the feedstock material? What is the process that is being used? And what is the level of lipid production? And then fermentation time it takes and references. You can very well click on this reference and get to know more about the process. What are the system they are using to produce good amount of biodiesel. Okay, so that is about the introductory slide of biodiesel from lignocellulosic biomass. So coming back to the biomass. So biomass, here, as I said in the first slide, here you will see what are the sources that can be used. As I was telling you, European countries and the United States, people are using energy crops because of the poor sunlight and the weather conditions. They used to grow the crops exclusively for energy purpose. Like corn is being grown for corn or tomato is grown for tomato vegetable. So here they want to grow the crops exclusively for using the cellulose for production of ethanol. So likewise, the other wood biomass, grasses, wood residues can also be considered as a lignocellulosic biomass. So it looks very simple. They are renewable, they are cheap and available in plenty. But if you look at the difficulties or challenges in this biomass deconstruction, it is very, very trickiest one. The reasons are, if you look at the composition here, you can see cellulose, which is a major polymer available in any of these biomass, followed by hemicellulose, lignin. So these are the three macromolecules present in any biomass, whether it is a crop residue or wood residues. Of course, wood residue will have more of lignin, but the proportion remains same. And if you look at the bottom of the slide, you will see here how the cellulose fiber is tangled with the hemicellulose and the lignin. So how to break this chain, how to break open this complexity and take the cellulose out and take the hemicellulose out, because we don't want lignin, especially if you are aiming for producing biodiesel from the sugars. So all we need is sugars. So these sugars have to be separated, for which there are two important processes. One is pre-treatment and the other one is saccharification. So this pre-treatment is the biggest issue, where you can take the lignin out. If you take the lignin out, then naturally the material gets loosened, and once it is loosened, you can get cellulose, hemicellulose separated. So these sugars can be subjected to saccharification or hydrolysis, and then you will get the simple sugars. So here, once you get the sugar, simple sugar like glucose or fructose, then you can attempt to produce biodiesel. Otherwise, if you feed glucose to the organism, it happily grows, undergoes glycolysis, TCA cycle, then it produces carbon dioxide end product. So all you need to do is you have to divert the pathway of oxidative carbohydrate metabolism to the lipid metabolism. Then you will get plenty of bio oil, that is microbial oil. Okay, so we consider this as a green process of producing biodiesel from lignocellulosic biomass. The reasons are so many. So here, all steps are considered to be green in nature. Nowhere it is chemicals, acids or base or anything used here. Most of the process are working as a green process, because the pre-treatment you will be using enzymes, lactase, lignin peroxidase, manganese peroxidase, etherase. So all the enzymes could be used for biodegradation. And if the enzymes, in the absence of enzymes, if you don't want to use the enzymes, what will happen? Either you can use acid hydrolysis, or you can use alkali pre-treatment, or hot water treatment, or solvent treatment, or you can use a steam treatment, or something like acid plus solvent treatment. So any of these acid plus steam treatment, so any of the methods can be used. So they are said to be physical chemical process, but here it is enzymatic process. The comparison of physical chemical versus enzymatic process or biological process is, the biological process is the slow process, but you will not get any inhibitors. You will see only the natural product as a end product, and all of the process, though it takes time, but the process works very easily, but the recovery of sugars will be very, very less. It takes longer time. So that is the biggest problem with the enzymatic process. Otherwise, this process works very fine. Even we have developed a process called Enzol. It is a trade process, patented one. So that works very well in the presence of enzyme lactase, solvent, and steam all together. So that process even goes up to the recovery of 60% of lignin. So that itself is the biggest achievement, that too in the biological process. But if you take acid treatment or alkali treatment, still you can increase the level of sugar recovery But the problem here is you will get lots of inhibitors. If you generate too much inhibitor at this stage, what will happen? This will affect the enzymatic process. So the enzymatic process should be neat and clean. For that purpose, it would be always better to use the enzymatic process of biodelignification. So once it is done, you will get the solid and the liquid at the end of this biodelignification process. The solid goes to this hydrolytic process, and then liquid goes to the bottom, where you can get the lignin fraction. So in the lignin fraction, it is possible to get vanillin and benzaldehyde. So you can see here the cost of the products. So this liquid is full of lignin. So this lignin, otherwise, if you are not aiming for the products, what will happen? This can be used as a steam generator, power generating system for the factory to run. So instead of the low value process, you can aim for the high value process. You can imagine what is the level of cost of vanillin. Vanillin is a flavor for ice cream. Benzaldehyde is an antimicrobial compound. So these are high value compounds. So you can always aim for this kind of products, so that you can make this as a whole, make the whole process as a biorefinery one. And before doing this biodelignification, so there are few processes which are said to be size reduction, sieving, and here also you can get the lignin portion and do the organosol process. So where you will get the lignin, and this lignin together with this, you can get to introduce this into the lipid fermentation directly. So this lignin together with this lignin and this lignin, it goes to the lipid fermentation directly. So there is a process which is an innovative process, but nobody does that process. And coming to the main process, where the solid portion of this biodelignification is sent to the hydrolytic process, where saccharification is done using cellulase and xylanase. Cellulase is required for 6 carbon sugars. Xylanase is required for 5 carbon sugars. If you put all together, both the enzymes will work on the pentose and hexose, will convert them into simple sugars, 6 carbon sugars. And at the end, here you will be getting both solid and liquid. The solid can be sent to the fuel generation or electricity generation system. Liquids can be transferred to another fermenter, where you will be using oleaginous microbes. So these oleaginous microbes will be allowed to grow in the lipid fermentation process. And you have to have a specific medium, so that will trigger more of lipid production rather than carbon dioxide production. So the first phase is to produce more of biomass, yeast biomass or fungal biomass, and then convert them into the lipid. And once you get the lipids accumulated in the biomass, so that can be subjected to oil extraction. So here, after this process, again you will get liquid and solid, and the solid goes to this process, where you will get the lipid extraction, and liquid is a waste, so it goes to the wastewater treatment process. So here the oil will be collected by solvent extraction or any other process, and then once you have the oil available, so the oil could be used for trans-esterification, and then after trans-esterification, you will get the biodiesel. So this biodiesel could be used as a transportation fuel. And besides that, there are plenty of possibilities that biodiesel could be converted into glycerol by a simple process. So once glycerol is produced, you can get other products like citric acid, propandiol, microbial oil. So all those things can also be produced here. So it is like a biorefinery concept, where you will get not only biodiesel, but also the other associated products produced along with that, including lignin and lignin derived products like vanillin, benzaldehyde, all those things can be produced. Okay, so this is in-depth what is happening inside the cell or outside the cell. So that is what it is indicated here. So if you take lignocellulosic biomass, in short it is LCB, you will get all these things: lignin, cellulose, hemicellulose. So what is this levoglucosan? Levoglucosan is a material, sugar that is obtained by pyrolysis of the LCB. So here we have included this. Some people used to do the pyrolysis and get this. So from all these things, whatever may be the source, whether it is hemicellulose or cellulose or lignin or levoglucan. So all the sugars, three of the sugars follow the same process, except lignin. Lignin undergoes a different process where you will get vanillic acid or hydroxybenzoic acid, protocatalytic acid. So here the metabolism is completely different. Our aim is to break down the lignin because it is a macromolecule, recalcitrant in nature. So once you break the lignin, you will get the low molecular weight lignin, maybe oligomers or monomers, and from this you will get some of the high value compounds. So that is our intention. Whereas from the sugars like cellulose, hemicellulose or levoglucosan, so it undergoes a different pathway, but all the pathways lead to the production of pyruvic acid. Maybe the glycerol 3-phosphate is the middle product in all the three pathways, but ultimately you will get the pyruvic acid. So this pyruvic acid can be the starting material for the biodiesel production. So from pyruvic acid, it undergoes decarboxylation to get acetyl-CoA. So this acetyl-CoA will be converted into citrate, and if it is converted into citrate, if it is not intended for lipid production, this will enter into TCA cycle and produces carbon dioxide. Whereas here you are diverting the pathway towards lipid production. So you favor the citric acid, and to get citrate to acetyl-CoA and acetyl-CoA, and then fatty acids, and then fatty acyl-CoA, and finally you will get the triglyceryl oil. So from triglyceryl oil, you can do the trans-esterification, get the biodiesel. So here so many pathways are there. See, for example, once you get the citrate, it will undergo another oxidation to get oxaloacetate, malate, and then from malate again it goes to the this pathway. And here also oxaloacetate is also going to citrate and then leading to fatty acid synthesis pathway. So this is how the inside the cell or outside the cell, once you feed the material with the glucose, this is what you are getting at the end. Okay, so that is about the biodiesel from lignocellulosic biomass. And here from now onwards, we will be concentrating more on the cassava. Cassava is a tapioca. You hope you all know about this. It is often called a root gold because the root is the product. So you will get plenty of starch in it. So because of the starch, even African countries, Ghana, Ethiopia, this is the staple food. Like rice that we are eating, cassava is a staple food. They make hundreds of products out of this cassava. You name any product, they make it. They make use of this cassava and then produce plenty of products. So these are some of the basic informations. Of course, it is a dietary carbohydrate energy like potato, rice, and then fifth among the starchy crops in global output. And the flour can be used as a dish, animal feed, textile. So many fermentation factories use this as a starting material. And many of the agro industries, especially sago production, starch production, this is a starting material. And if you process the cassava root tuber to produce sago, what is the issues that we are facing? Often this industry, sago processing industry, produces plenty of waste, because if you want to process 1 ton of tapioca roots for production of sago, it consumes 25,000 liters of water. You can imagine how much water is being left out in the process. So ultimately, you will release 40 to 50,000 liters per ton of sago that is being processed. And in this case, if you release this much amount of water, if it is a good water, you can use it as such for irrigation or recreation or any other purpose, even for washing back onto the same tubers. But this water has lots of contaminants in the sense COD, BOD, cyanide, all those things are present in this water. You can imagine how to let out this 40,000 liter per ton. If you are processing 10 tons, you can imagine how much water is being processed. Though it is a small scale industry, there are about 70 tons of cassava is being processed in a season for a small scale industry. So you can imagine how much water is being left out. So if the water is being let into the field for irrigation, it causes so many issues. Already, tuber is known for cyanide poison. Besides that, if you let the water to irrigate the crop, then again the cyanide content of the soil will get increased. BOD level, COD level, all these things will pollute the soil and leads to polluting the crop which we are going to eat as a food. You can imagine. So because of that reason, Central Pollution Control Board has warned this industry as a red industry. So because of this red industry, huge amount of water, environmental hazards, people wanted to make use of this wastewater for efficient utilization or reuse or recreation purpose. So this is the whole process of cassava sago processing or starch processing. If you take the starch, so initially the root is being washed, and then here you will get two type of wastewater and peels. So these are the waste in the first stage. And in the second stage, rasping process where the starch extraction starts. So here also you will be using some amount of water. And at this stage also, after the washing, you will get the solid waste as well as cassava bagasse. So this is also another waste. And after that, starch milk is obtained and it goes for sedimentation. And then here you will be making them as a starch cake. So this starch cake can be used either for starch making or for sago making. So in this case also you will get liquid waste in the form of pulp or suspended solids. So there are three types of waste generated in the whole processing of sago industry, of which water is the major waste. So if you look at the process, see here the water is being is being stored, and even for after extraction of starch, the starch is present in the tank, and over the starch you can see the water, and it is a very tedious process to manage the water that is being let out of the industry. So here we have a solution of using this water, how best we can manage, how the issues can be solved. Say, for example, you will get good amount of starch, like 4 to 7 grams of starch is available in the wastewater. And here, as I said earlier, the water is highly acidic in nature, cyanogenic. Cyanide content is around 4%. And then BOD, COD level is very high. And to address these issues, we have to make use of this water for various other applications. Other application means you can produce biogas using this water. That is another approach. Many industries are using this. And besides this, there are so many issues like increasing greenhouse gas emission, depleting the fossil fuels. Another opportunity available for us to make use of this starch wastewater to produce some useful products. And another alternative for this problem is using the single cell oil producing organism, which is alternative to plant cells. And while doing so, the food versus fuel debates or competition can be minimized, because this is not going to be either food or feed. So this can be, these questions will not arise. And while doing this biodiesel production and the co-products production using wastewater, you will get several advantages. The reasons are these are not affected by seasonal differences. You can, if you have the wastewater available in starch, good amount of starch, you can produce the biodiesel at any time. So all you need is, though the crop is seasonal, the production is not seasonal. and elevated lipid content. You cannot imagine 70% lipid content in any of the oil that you get, whether vegetable oil or animal fat. And the capacity, broad range of carbon sources. These organisms grow on any of the carbon sources. Life cycle is short, and the similarity with the vegetable oil in fatty acid composition. So here, our interest is like biodiesel production can be approached in a biorefinery concept, and ultimately you will reduce the pollution caused by this wastewater. So with this intention, so we started our experiments. So here we explored the possibility of using this sago wastewater for various applications. On one side, what are the bioprocesses available? Pre-treatment is one bioprocess, liquefaction, saccharification, digestion, fermentation are the bioprocess available for you to make use of this starch wastewater. And the microbes, you can use any type of microbes. Of course, we have experienced good results with the yeast and fungi. So that's why we have stuck with the yeast and fungi. And among these two organisms, yeast works very well. The conversion rate and the yield, the productivity, all these things are much better than the fungi. So all of our results will be on the yeast-based biodiesel production. So here, yeast is also said to be a biomass. Because once you grow the yeast onto the wastewater, you will get good amount of biomass. So this biomass is used for production of the microbial oil. So it is a kind of biomass to bio oil production, biodiesel production. So on the bottom of the slide, you can see the biofuels, organic acids, biosurfactant, other biochemicals. So these are considered to be the value-added products. If you have any specific questions, you are most welcome. Otherwise, I will move on to the next slide. Okay, so I don't want to spend much time on this because this takes a lot of time. Because we started looking after the wastewater, did some enrichment. After doing some enrichment, we were able to get good amount of isolates, microbial isolates. Some of them were yeast. So these are the two yeast which we have isolated from the sago wastewater by doing biotrap-based enrichment. And these are some of the four different fungi. They are also accumulating good amount of lipids in their cell. So we wanted to use this. So here is the list of organisms. So we have about 7 different organisms available and are isolated from the sago wastewater. Okay, so this is an experiment which is very critical to know about whether the organism which we have isolated are able to produce lipid or not. And in order to screen the organism and to find out whether the organism is able to grow on starch, we have to know the amylase activity of the organism. Because starch is a feedstock here. Starch is a substrate for the organism. So if the organism has a good amount of amylase activity, these organisms are said to be, they are able to grow on the starch-rich wastewater. So with that idea, we have isolated and screened all the organisms for amylase production. And the next important activity is, so that means this shows that the organisms are happily growing on the starch-rich wastewater. And another screening is whether these organisms are growing. Yes, they are growing. After growing, whether these organisms accumulate lipids in their body. So this is an experiment to show that these organisms are accumulating lipids in their body. So that means these lipids could be a resource for producing bio-oil or biodiesel. And other confirmations that we have done here are the oligonicity confirmation by flow cytometry analysis. So here we wanted to screen these organisms, whether these lipids are able to show any fluorescent intensity. And then here also we wanted to see how much lipid percentage these organisms are producing. So we have taken 4 different organisms. This is yeast, and these 3 are fungi. and compared with the agricultural waste-based lipid production. And it is not comparable with this biomass, but to certain extent, like 30% or 40% of this, the lipid can be accumulated in this yeast, and these are very low at rate of 30% or 25% or 20% biodiesel. And if you want to compare the yeast strains with the flow cytometric data, so here we have a forward scatter, side scatter. So all these things shows that the yeast produced lipids are confirmed within this organism. And once you have the yeast biomass or fungal biomass available, so what is the next? Whether this biomass has a good amount of features that are available for the conversion. So here we have the data of proximate analysis and ultimate analysis. And the proximate analysis give you some information like what is the moisture content, volatile, fixed carbon, ash, and other things. And then the ultimate data give you CHNOS, all this information. And here the take-home message is that yeast biomass cultured from sago wastewater can be used for fuel purpose. So that is a message. If you compare the yeast biomass with these parameters of the lignocellulosic biomass, whether rice husk, sawdust, wheat husk, poplar, wood, so this is much better than the other parameters of other biomass material. For ultimate data also, so this gives good amount of good comparison with the data of the other biomass material. So this is the message. And if you want to compare the calorific value, because calorific value is very, very important for the biodiesel to run the vehicle. So here comes yeast biomass. You can compare the yeast biomass with the other materials, rice husk, sawdust, wheat husk, and it is comparable. It is not very poor compared to other biomass material. Okay, so you have a good amount of yeast biomass available. So how to grow this yeast onto the wastewater and how to produce this lipid? So here comes the kinetic data available. This will show that the blue lines are yeast growth biomass, and then this blue line, dark blue line, is the amylase activity, and this one, orange line, is the lipid production. And you can see here one that comes from top to bottom. The red line is considered to be the starch utilization. So forget about these two things. This is the growth, amylase, and these two are the critical ones. One that comes from the top to the bottom, one that goes from the bottom to this place. So the lipid production and then starch utilization, you can see here there is an intersection, and you see here this is the peak area where you will get good amount of lipid production. So this lipid production of yeast and the fungi are compared, and here when you compare these two, the productivity is much higher for the yeast because it gives 48.59% of lipid content with the yield of 1.2 gram, and here it is 37% with 1.4 gram lipid yield. But it takes longer time, like 240 hours. Here it produces within 120 hours. So that means the productivity is much higher. And the starch consumption rate is also 84% here, and it is here only 30%. And with the 10 gram per liter of starch, the organism yeast grows happily, whereas here it requires 30 grams per liter. You can imagine how expensive the fungal based fermentation is. Okay, so once you have the lipids produced from the biomass, you can analyze whether these lipids are productive enough or comparable with the other fatty acid mix. So here is the data which shows the profile, FTIR profile of day 1, day 3, 5, 7, and 9. So there is a little variation, but not much difference between the day 1 to day 9. Of course, there is a limited variations available. Say, for example, amide 1 and 2 are available here, which is not seen in day 1. So likewise, CO stretching is just started here, which is not prominent in this day one. So likewise, if you have the extracted lipid, the red line is extracted lipid, and the green line is biomass before lipid extraction, biomass after lipid extraction. So if you compare this data with the FAMIX standard, so the FAMIX standard is comparable on many of the profiles. Not all, but many of the profiles are almost similar to this FAMIX. So that shows that the fatty acid composition required to be a biodiesel are available in the lipids that are produced from yeast biomass. So that is a message that we wanted to share here. So for all the 16 peaks that you are seeing here are listed here. So each wave number represents particular fraction here, like CO stretching, CH3 bending, all these things are said to be corresponding to the main biomolecules like lipid, phospholipid, and so on. Okay, so here is the comparative analysis of fatty acids of Candida tropicalis, which is a yeast with soybean and jatropha oil. So you look at the profile of soybean oil and look at the profile of jatropha oil, and here is the yeast which we have done in our experiments. So here, in order to be a good transportation fuel as biodiesel, there are two important acids. Although there are plenty of fatty acids are available, but oleic acid and arachidonic acid are the two important acids that should be in good value. So what we have achieved, the yeast lipid FAME mixture, you have both oleic acid and the arachidonic acid. This shows that it is a good biodiesel. So the profile of the FAME fatty acid analysis from starting from day 1 to day 9 are presented here. As the day grows up, then the proportion of biodiesel fatty acid is also getting increased. And here, this data shows fuel properties of yeast biodiesel. Here, we are comparing the yeast produced from yeast biodiesel produced from sago wastewater with all the other biomass, like same yeast with a different organism, and jatropha biodiesel, soybean biodiesel. So the comparative data shows that in many of the parameters like kinematic velocity or oxidative stability, all these things are much better. Oxidative stability and cetane number are the two important parameters which are said to be much better than the other biomass material, biodiesel produced from other biomass material. So higher relative to the microbial oils, which implies that longer shelf life of biodiesel of the yeast produced one. And in general, high cetane number provides better ignition properties for the biodiesel. See here, 61, which is not seen in any of the biodiesel produced from biomass materials. And here, this is another comparison of the fuel biodiesel produced with the standards. ASTM is another standard, EN, European Union standard, IS standard. So with all these things, we are seeing the kinematic viscosity and the iodine value, which are considered to be the two important parameters which are comparable or higher in many of the occasions. So this also shows that the biodiesel produced from yeast is on par or above the standards of the biodiesel produced from either jatropha or any other standard materials. And once we have the biodiesel produced and evaluated, so we wanted to scale up the process to a higher level, from the laboratory scale to the higher level, maybe in the 5 liters reactor. So for which we have developed the airlift bioreactor. So this airlift bioreactor works very well for the yeast multiplication. So here we are using the wastewater as a feed, and the yeast grows happily and produces good amount of biodiesel. So this data is also supportive enough to take the technology to the next level. And here we have also done some RSM to get to know what is the optimal biomass yield that we are getting, what is the lipid yield that we are getting in the optimized carbon source, optimized nitrogen source, and optimized air flow rate in the reactor that we have developed, airlift reactor. So here the optimized data are present in the left-hand side of the slide. So the starch with the utilization of 89% of the starch, the lipid yield will be 2.68 gram with the lipid content of 45%, and the biomass produced is 5.9 gram per liter. So this is the final data that we have obtained. And if you want to compare the mass and energy balance, so the final sheet will give you the benefit cost ratio of 3.21, and with the 4.5 years of payback period, you will be able to get a good amount of revenue through this process. And the bottom of the slide on the right hand side, you see here, if you take 1 liter of sago wastewater, how much biodiesel could be produced? 2.3 ml per liter of sago wastewater. So per industry, for any industry, small scale industry, in a season, they handle 70 tons of cassava tubers. So with the 70 tons of cassava tuber, you will be able to process this much 13 tons of sago per day. And with the 13 tons of sago, you will get the biodiesel of 750 liters per day. You can imagine for 6 months, from September to March, which is the peak season, this much biodiesel could be 134,500 liters could be produced the entire season. So it is a good amount of biodiesel. Only thing is the technology is not taken up to the higher level. So there is a reluctance among the small growers, but that's the reason why we are unable to match with this process. And parallelly, besides biodiesel production, the growing the organisms onto the biodiesel also decontaminate the wastewater, because as I said in the beginning, nitrate is a pollution, phosphate is a pollution, and then ammonia is also a pollution. So these ammonia, nitrate, phosphate could be decontaminated. So the levels can be reduced. Say, for example, the nitrate level can be reduced to 0. So 100% of nitrate can be reduced. And similarly, ammonia, 98% reduction. Phosphate, 85% reduction. So almost 0 level, we are making the water free from nitrate, phosphate, and ammonia. And on the other hand, we are also making the water free from COD, BOD, and cyanide. Not completely free, to a certain extent. The COD level could be reduced to the tune of 83%, and BOD to the level of 92%, and the cyanide to the level of 78%. So we are unable to completely remove the cyanide, but it is within the limits of the standards that is being prescribed in any of the irrigation water. So on the bottom of the slide, you can see the comparison of what we have achieved, what is present in the raw wastewater. So the treated wastewater can be fed to the crop. So where we have tried maize as a test crop, it grows happily, especially the diluted wastewater can be, treated wastewater can be used for irrigation purpose. Okay, so that is about biodiesel production. So having said the starch wastewater could be a feedstock for producing biodiesel, what are the other things that we can produce using the same organism, yeast and fungal cultures? Okay, so sir, still we have some time?
Sir, yes, sir.
Okay.
Up to 9:30 we have, sir.
Oh, up to 9:30. Okay.
Yes,
So do you want some break?
No, go ahead. Go ahead.
Okay. Okay. So so far any questions from the participants about the biodiesel? So if not, I will start here. Maybe at the end you can ask your questions. I do not know how long this will go. The organizers said that you can go up to 9:30, but I'm not going to go up to 9:30, but another half an hour. Okay.
Sir, after completion of your session, we will ask, sir, any questions or any doubts we will discuss.
Okay.
Yes, sir.
So maybe in another 15-20 minutes I'll complete, and then give some more time for the discussion.
Yes, sir.
Here, so two important products. Of course, lovastatin, you might be knowing. Amylase, we have seen in the beginning of screening of the organism. So we can also make amylase production as a good revenue process by using this organism. Not only the yeast, but also the fungal system can be very well used. So these are the activities the organism produce using the wastewater. On the right hand side of the slide, you can see using this microbes, you can produce lovastatin. You know what is lovastatin? Statin is in general used for lowering the cholesterol level on the human body, not only on the human body, but also in the animals, birds, cattle. So you can reduce the cholesterol level by using this lovastatin. If you have the lovastatin producing organism, this can also be fed to the animal as a probiotic. So you can aim for high value product like lovastatin, and this lovastatin is produced by this organism. So we have analyzed, quantified, and good amount of lovastatin is produced by this organism besides amylase production. And another important feature of this SAGO wastewater process is microbial fuel cell. So we have not done anything on that, but this is a literature information. So what I'm trying to say here is by using starch wastewater, because of the starch and the organic content present in this wastewater, it is possible to produce electricity using the microbial fuel cell approach. And this is well-known technology. So for which we need to have the wastewater source and then the microbial source, and then put it in the fuel cell, you will get the electricity produced, and also you will get parallelly good clean water. The water is also treated wastewater can be used as a clean water for irrigation or recreation purpose. Besides that, you will get electricity to run the factory. And then these are some of the methods, types of microbial fuel cells available, and energy output from SAGO wastewater. I'm not going to go in depth. I will share the informations to you, to your organizers. You can very well get this information. So this also, we have not done anything on the biomethane and biohydrogen. So biomethane productions from SAGO wastewater is one of the oldest technology. Even now, many industries in the Rasipuram, Namakkal, they are practicing this methane production. And you know, it is a multi-step process. And here, the hydrogen production is a photobiological and dark permutation process, where straightforward process. And many people are trying to use this SAGO wastewater as a feedstock for production of biohydrogen. This is also available. And the method of biodiesel, biomethane production are listed here. Okay, so in addition to this biodiesel, biomethane, biohydrogen, you can also produce some short-chain volatile fatty acids. So these short-chain volatile fatty acids like acetic acid, propionic acid, butyric acid, valeric acid, all these things are said to be good revenue-generating bioproducts that can be produced using the acidogenic bacteria. And besides that, biosurfactant is another picking up product. And these microorganisms are able to produce biosurfactant, which has a value in the environment, biomedical, medicine, cosmetics, textile, agriculture, food, and other places. So it is up to us to make use of any of the process of our choice besides biodiesel, and then get revenue. Finally, these wastewater can also be used for producing pigments, microbial pigments. I think lovastatin already we have seen. Okay, I'm done with this. And of course, this is a summary slide where you can get many products out of this SAGO wastewater as a starch. sago wastewater, starch wastewater. And in this process, besides producing this value-added chemicals, you can also get the cyanide degradation, and you can get the oleaginous microbes developed through this process. And the water can be used for irrigation, recreation purpose, and the environment gets cleaned, and the labor saving, and you can also provide employment to the people who are around this industry. So many benefits are there. All we need is we need to have a techno-economic analysis to work out economic feasibility of the process. Otherwise, this is a good technology, and that patent of biodiesel production using sago wastewater was published, and we are yet to get the award of the patent. So this is our group, which was taken in 2019. And this person worked very hard. She's a microbiologist. And this person is engineer, renewable engineering department. And we have other people also here, like physiologist, pathologist, and chemist. So it is like a heterogeneous group that we have been working on so many projects on plant microbiology, biodiesel, bioethanol, biocatalyst, so many areas of our work. So it was a wonderful experience that we had in the past, but now the number has come down. So here our mentor, former Vice Chancellor, and he is in the private college here working as a director. Earlier he was in VIT as a controller of examination. My mentor, postdoc mentor, Dr. Julie Maupin from University of Florida, where I stayed for about 4 years as a visiting faculty, biological scientist, and postdoctoral fellow. I learned a lot about the protein engineering, and other molecular biological techniques were learned in her supervision. And the bottom line are our lead collaborators. The earliest collaboration was with Russia, where we have worked on the biodiesel production, biofuel and biorefinery chemical production from lignocellulosic biomass material. And this person, TDH Bug and Word, is both are from the same institute, University of Warwick. This person works on enzymes, and this person works on proteins for plant microbe interaction. And this is one of our collaborator from University of Wageningen University, Netherlands. And in fact, when I was attending a conference in Maastricht in 2014, he drove 80 miles and then picked me to his institute and allowed me to stay there for about 7 days. And he took around the entire university. I was surprised to see the university, because the entire university, faculty in the entire university are not paid by the university or the government. So they all paid by the vendors. So every faculty is attached with the vendor or private firm, and the entire team under the faculty are working for the company. Once the technology is commercialized, then they will get the revenue out of the technology they are developing, and the faculty salary is made by the company. So that means the professors over there are faculty of university, but paid by the firms of the beneficiaries. And these three are live collaborations. He is from University of Tokyo. Still we work together on different projects. He used to visit every year. I'm also going there year after year and serving the job of adjunct faculty. And here this person is from South Africa, University of Zululand. We work together on hydrogeomicrobiology. And this person is from Pu Li from China, Chang'an University. And so far I made 3 different visits, 2 visits in the last year itself. And this year I'm going to go there by the month of May. And these are our funding agencies who generously funded for our research. I will stop here. If you have any questions, you are most welcome.
Dear participants, you have any questions?
Okay, I see chat box.
Yes, sir. Sankaran, sir.
Okay. Any specific questions?
The questions.
Participants, you want any interaction with the expert?
Sir, why biodiesel is not commercialized like diesel as of now?
Yes, it's a good question. Some policy interventions are to be there. Like a bioethanol, biodiesel is also a renewable source. The problems are so many. Like production cost is much higher than the normal diesel production, and for which government support, policy support, subsidy are highly essential. If you want to look at the environment to be clean, if you want to support the farming, if you want to support the bioprocess, definitely the government has to support in a big way to promote. And once you promote this, once the technology is perfected, you will make the process very cheap, and then further support may not be required. Like subsidies being given to some of the small scale industries. Financial support is given to the startups. So likewise, this industry needs lots of support, financial support, policy support, subsidy support. Then only this industry will grow. Once it grows, then you can stop the support. So that is the main problem. Otherwise, it is a viable industry. Still, with the lack of financial support, it is lying down. Even for bioethanol production, it is a very good process, and many industries are having facility to produce absolute alcohol, from where you can get the beverages. And parallelly, you can also aim for producing the transportation fuel. So if you are getting good amount of remuneration from the beverage, who will go for transport fuel production? So that is the issue. So once government supports, then this will scale up and reach the largest production. Otherwise, it will be very difficult.
Sir, nowadays we are having waste, that is synthetic oil,
Yes.
which is coming from waste to energy.
Cooking oil.
Not cooking oil, synthetic oil, waste plastic oil,
Oh,
pyrolysis oil.
yeah.
That is also coming into the field.
Yeah,
That
cooking
can be
oil is
also.
coming into the field, and synthetic oil is coming into the field. You know, many industries are now focusing on flavor and aroma compounds. You know, the orange peel is a good resource for aroma oil production. And similarly, people are highly innovative. So this innovativeness leads to so many advantages. But I do not know the cost of production of synthetic oil, because if the cost is very cheap
Yes, sir.
comparatively
Cost comparatively, it will be 45, 50 rupees.
per
When
liter.
compared to per liter, but biodiesel cost more than 300 rupees,
Uh-huh.
roughly. And one more
Yeah.
thing, biodiesel is highly acidic. And I don't know what about synthetic oil, but synthetic
Mm.
oil have the problem in long time usage. Anyhow,
Mm-hmm.
all the applications need some maintenance.
Yeah.
But people are saying long-term usage of biodiesel and plastic oil it's a huge drawback. But diesel engine or petrol engine or any kind of application need maintenance. But
Definitely.
I don't know why people are commenting on the only the long usage of biodiesel and synthetic oil over the engines.
Mm.
It's a big question.
Yeah, I'm not aware of about the cost and other issues associated with the synthetic oil. But once it comes to oil, any oil can be used. Only thing is the quality of the oil. The essential fatty acids required to be considered as a biodiesel. If it is available, then that can be used. So cost matters. For every oil, cost matters.
What kind of oil can be converted into biodiesel, sir? For an example, it is possible to convert.
Animal source of oil can be converted. Jet oil can be converted.
That
Any
is
vegetable oil can be converted.
dry glycerol type of oil. That oil
Yes,
having weak fatty acids.
yes, that is a starting material.
Is it possible to convert eucalyptus oil or pine oil into biodiesel? It doesn't have any fatty acid.
Pine oil.
Eucalyptus oil. These are the some type
I
of tree
think
oils.
eucalyptus oil may not have enough fatty acids. Pine oil also may not be having enough fatty acids.
So
Yeah,
most
those
of the
because fatty acid is most important for considering
esterification.
it to be biodiesel. So if it doesn't have a fatty acid, then there is no meaning in using those oil.
But the problem in this oil is they have lower C10 rating, which you highlighted for
Yes,
even your biodiesel. It's higher C10 rating, around 61 number.
the pine oil.
No. The 61 C10 rating is you disclosed in your
Yeah,
PPT.
in our system, but that is important for the oil to be considered for biodiesel properties. But for those other oils, fine oil, I don't think they have a good amount of fatty acid proportion as well as the C10 number. I'm not sure about those oils. I think research is also not much concentrated on the pine oil and eucalyptus oil. So they are, I think, a bit expensive than this oil. The cost itself, because 50 ml, 100 ml is being sold 150 rupees, 200 rupees.
No,
Then you
no,
can
no, no,
imagine per
sir.
liter.
No,
Per
no,
liter.
no, no, sir. Jetrop oils cost around 300. Nowadays, Jetrop oil, last time I purchased, it cost around
No, no,
800.
I'm asking you, I'm telling about the pine oil and eucalyptus oil.
Pine oil comes under 400 something, for
Yeah,
around
that
400
is
to
a bit
300.
expensive than the other oils.
No, sir, nowadays, Jetrop oil itself, I'm getting market 800 rupees. Last time I bought for 900 rupees.
900 rupees per liter. Huh?
Because availability of oil is not easy. Even cotton seed
Because
oil is
the
not.
crop, domesticated crop, failed to produce, failed to multiply in a large way. So that's the reason why the Jatroba is not picking up very well for biodiesel production, because they were facing lots of problems. So whenever we domesticate the wild crops, this will be a problem.
Okay,
And the
okay, sir.
DST has also funded huge amount of money during the year 2000s. But it is unfortunate to maintain the plantations. Plantation faced a severe problem of maintenance, pest and disease, so many issues. Even the oil extraction were not successful during those times. But the people have succeeded in oil extraction, but the crop is not picking up very well.
Okay, sir. I understand.
Yes.
Thank you for your response, sir.
Oh, thank you very much. Any other questions?
So next, Francis Bharati sir, do you want to discuss anything? Francis Bharati sir and Rohit Kumar sir, you
Yes,
are
sir.
raised your hands.
Yeah. Sir, how we find out the quality of fuel, biofuel?
Quality of biodiesel.
Biodiesel.
Yeah, there are standards, ASTM standard, EN standards. You have to compare the biodiesel produced by your process with the standards. Set of standards are available. So those standards are freely available. So if your biodiesel produced matches with the standard, then this can be a transportation fuel. And then you have to test verify with the engine. What are the other features like oxidative stability, C10
Uh,
number? So those
sir,
uh,
sir, their calorific value for
calorific
the
value
use
is
of.
very, very important. Before proceeding, calorific value is very, very important for any feedstock to be considered.
So they are only
So
a
I was
bomb
mentioning,
calorimeter or some other instrument also there.
we have all the machines available here because we have a renewable energy engineering department where you will have all the machines. And we, in our microbiology department also, we have a GCMS with all the fatty acid standards loaded in the system. It is available.
Okay, thank you, sir.
Thank you. Welcome.
So Francis Bharati sir, you have raised your hand. Do you want to interact with anything, sir? Any other participant
hand
want to
raised.
interact anything?
Sir, good evening, sir.
Yeah, yes, madam.
Sir, I am Lakshmi Prabha, sir. Sir, I want to get some clarification on catalyst using for biofuel production, sir.
Catalyst for biodiesel production, right?
Yes, sir. Yes, sir. Whether homogeneous or heterogeneous, which one is give more effective during the processing, sir?
So we use alkali-based method, which is
Okay.
giving very good effect.
Okay, sir.
So it depends on the feedstock material. If the material is homogeneous and it works very well, we have to do some trials, and accordingly we have to use this catalyst
Okay.
for
Whether we go,
transestimation.
okay. Whether we go for optimization for that, sir?
Yeah, optimization is required for every process. Optimization is required.
Okay, sir.
And
Okay, sir. Thank you, sir.
methanol alkali combinations will work very fine for most of the process.
Okay, sir. Okay, sir.
Yes.
Okay, sir. Thank you, sir. Thank you so much, sir.
Welcome.
Sir, there is one message from
yes.
Prashant. Already EVs came to the market with the low cost of running, but why we need to run the vehicles with biodiesel?
Which one?
Sir, Prashant Dobla. Sir, I think you are...
Chat box, I'm opening now.
Yes, sir. Yes, sir. Yes, sir. This one, sir. 9-19.
Oh, yeah, here.
Yes, sir. Yes.
Already EVs, electric vehicles. Yeah. Very good. Why do we need running the vehicles with the biodiesel? So if electric vehicles are much cheaper and available to the common people, then we don't have to rely on that because it is environment friendly, cheaper. Yeah, this is just an alternative, but electric vehicles may not be accessible to all the people who are in a place where they may not have a 24 hours electricity. So still we have some places. So in those places, if it is cheaper, affordable, then that is a good suggestions. It's a good one. So the biodiesel is alternative to the diesel. Bioethanol is alternative to the petrol. So that way we have to take it. I see some other persons raised their hands. Prabhaharan. Is there any facilities available or allowed to do work on biomass biodiesel production? How can you approach that? Give your suggestions. Prabhaharan, from where are you?
Prabhakaran sir.
He asked this question, but anyway, I will answer. Here, the IIT Trichy has...
Prabhakaran sir from Prairie Institute, sir. He messaging. I think he have a problem in mic. Prairie Institute.
Terry, Delhi.
Yeah, Perry Institute.
New Delhi. Okay. So there are institutes even in IIT Delhi, Dr. Gopal's laboratory. There are so many people available. They can help them. In Terry also there is a person, Chakravarti. He works a lot on biodiesel. And there is one lady, I forgot her name. She also works a lot on biodiesel. Terry, so many people are there because we have been there in 2010 or 11 for a conference. So during that time, we met those people. And it is up to you to look at their profile, institute, and you can get training. So we here also we support the training. But right now, the biodiesel work, we have stopped it because we have another pressing need for plant microbiology. So we are on hold now because earlier we had engineering students. So to support engineering student, and also we have got a grant. We started that work, but that work is still on hold. But if you get any good student like you, or any research fellows like you, we are happy to initiate that work and then help you. So we are also open for any kind of research, like collaborative research or part-time research or training. We are open to all these things. But the idea is, Lakshmi Prabha, idea is to use biomass. Yes, biomass produced by sago production. Yes. Answer, yes to the Lakshmi Prabha. Perry Institute, Prabhaharan from Perry. Perry means P-E-R-I. Perry Institute from Chennai, Tamil Nadu. Thank you. Perry means? I don't know. Oh, it is a college. Okay. Thank you. Thank you very much. Any other questions? Okay.
Participants.
Let me share one more information here. I will stop sharing this and present another slide. So do you see a promo here? ICES 2025. Do you see this slide?
Yes. Yes.
Yeah, this is a conference which is being organized from 17th to 24th August 2025 at Durban, South Africa. So our collaborator, Professor Vetti Murugan Elumalai, is organizing this conference. So if you are interested, you can go to this site, ICES, and then register yourself. And nowadays, there are plenty of financial support available. DST, SERB, DBT, every agency is giving travel support. So you can avail the travel support. If you need any help, you are most welcome to contact me. And I can get you some discounts on the registration if you contact me. So that way we can help. So here from TNAU, we are planning to go for this conference, maybe around 10 people. And another institute, Avinash Lingam University, also many faculties and students showed interest. There might be more than 10 people going from that institute to South Africa, because recently we signed the MOU with this University of Zululand. So we wanted to reciprocate by attending this conference. So more importantly, the geological excursion from 21 to 24th August will be much interesting, and you can feel like visiting the forest, visiting some important places in that area. Okay, I will stop at this stage. If you have any questions, you are most welcome now. Any questions about the conference?
Dear participants, any questions, or otherwise we go for an summary of report? I think no more questions. Okay. So now I welcome Ms. Aswini, Assistant Professor Pharmaceutical Technology, to deliver the summary report of expert talk. Aswini ma'am.
Thank you, sir. Greetings to all. I'd like to express my sincere gratitude to Dr. Svhec sir for sharing his valuable insights. I also extend my appreciation to all the participants for their enthusiasm and active engagement. Here is a concise summary of the current session. It is consists of different levels of biomass and biodiesel and every other byproducts. We're starting from the cellulose biomass from oleaginous microbes that contains 20 to 70 percentage of hemicellulose and cellulose. It is also known as the single cell oils, which produce microbial lipids, which especially the lignocellulose biomass, which is used for biorefineries of lipids. The source may be the grasses and other plant products, and which contains basically of cellulose and hemicellulose, which can be converted into sugars using pretreatment and saccharification. And for this process, they have used the enzymatic process and green process for the recovery of biodiesel from LCB by removing the lignin, which can also be used for power generation. And biodiesel can be converted from the alcohol and then other products, and hence the microbial pathway, which is also described by our esteemed guests, and their pathways are starting from commonly for all the three sugars having the pyruvic acids. And next we go for the casva, which is also known as the tapioca, which is called as the root gold, and this is used in the sago industry, which is also the season based of agro industry. And disadvantages may be the release of high amount of wastewater as effluent, which especially contains cyanide as the major constituent, and hence it is called as the red industry due to its high amount of cyanide content. And why we are using the sago waste water, which is because of biorefinery, because to produce biogas and also especially to produce single cell oils. And advantages of this will be the high lipid content, and it can be used in all seasonal, irrespective of your differences in the season. And our present vision is to produce biodiesel from that effluent and also remove the wastewater effluent to the environment. And it also contains and explained by our professor about the biodiesel, which is especially of the microbial pathway and bioprocessing engineering, which contains especially the yeast, which contains high amount of biomass protection compared to other fungi and algae, which produces the biofuels, organics, acids, and biosurfactants. The yeast biomass analysis are also carried out, and yeast biomass can be used for fuel purpose also, which contains a high calorific value, and also kinetics data helps to understand the lipid production by yeast biomass when compared to fungi biomass. And FTR analysis are also showed for comparable of its microbial lipid extraction, and it also contain high oleic acid and arachic acid, which is essential for biodiesel analysis. And also candida, which is also a yeast which is used for sago processing, which produce the biodiesel, which contain high oxidative stability, and cetane, which shows longer shelf life of biodiesel. And for large scale production of this each biomass, there is a reactor which is especially designed by, and that is also known as airlift bioreactor to produce the biomass from yeast. And he also showed us about the mass and energy balance and also the cost economics of their project. And finally, we got concluded with the decontamination of the effluent with the of NHC, that is especially ammonia and nitrate and phosphate, which is reduced and decantation and released to the environment. And other byproducts, which is also produced from this each biomass, is the in the lipid production is the major one is the amylase and lovastatin, which is also used for lowering the cholesterol. And in the literature, especially he also showed about the microbial fuel cell, and other things are biomethane production and biochemical products from the yeast biomass, and also the biosurfactant and pigmentation production from biomass, yeast biomass. And that's all the conclusion and summary of our session. And thank you one and all for showing interest in our session. Thank you once again, sir, and thank you all the participants.
Thank you, madam. You summarized everything.
Oh, thank
Very
you so
nice.
much. Thank you so much, sir.
Welcome. Thank you.
Thank you, sir. Professor Saladevi, ma'am.
Yes, sir. So yes, 60-day FTP program has come to an end, I think. On behalf of Sri Venkateshwara High Tech Engineering College, I would like to extend my heartfelt gratitude to our Honorable Chief Guest, Professor Sivakumar Udanti sir from Tamil Nadu Agriculture University, Coimbatore, for delivering such a discerning and engaging session on microbial biodiesel production from biomass. Your presentation has provided us with a deeper understanding of the role of microbes in biofuel production, sustainable energy solutions, and the future potential of biomass-derived biodiesel. The way you explained the scientific advantagements and challenges and industrial applications was truly enlightening and thought-provoking. Your expertise and patience for this has certainly inspired us all. Thank you very much, sir, for your vivid and fruitful session.
Thank you, madam. Thank you very much.
Thank you, sir. Next, I would like to express my sincere appreciation to 6th Atal FTP coordinator, Dr. P. Ramalingam sir, and organizer Mr. Srinyana Sambandam sir, for making the first day session possible and ensuring its smooth execution. Thank you, sirs. Next, thanks to our respected faculty members, researchers, students, and all participants for their keen interest and active engagement in today's session. Once again, I thank one and all. Here, there is an announcement for the participants. All the participants are join for Day 2 session tomorrow at 6 p.m. sharp. Hope you will be punctual and join us tomorrow. Thank you. Have a good day.
Thank you, madam. Thank you. Bye.
Thank you, ma'am. Thank you, all the participants. So we are going to signing off today. So tomorrow at day 2, the session will be starts at 6 p.m. sharply. The session link will be forwarded at WhatsApp group. So thank you so much, sir. Thank you all. Feedback form already forwarded in WhatsApp group simultaneously in message. So kindly fill the feedback form